So guys, you ready? Chairs. Yeah, I'm just kind of testing out, seeing what makes them different. We've tried everything now. Table to table, floor to floor. Now it's floor to table. Oh. That's ready. Yeah. Let's go. Alright, I guess the first thing I want to talk about is just like overview of the TST and our plan, you know? So it's like we're here. This starts Wednesday and Thursday, right?
Yeah.
And then, huh?
What's that stand for?
Wednesday, Thursday.
SSMT.
Saturday, Sunday, Monday, Tuesday.
Oh, okay.
Okay. Wednesday, Thursday. Okay.
Okay.
So did they tell you it was 4.5 hours? I'm just assuming it is. Yeah?
Yeah.
So I'm assuming it's like the IMO, right? 2 times 4.5 hours. And then it's times 2 again, right?
Yeah.
And so there should be 3 problems per exam. Did they say that?
Yeah. I think so.
They said that? Well, it would make sense, right?
Yeah.
And so that's 12 problems. That means you hopefully should get A1, A2, A3, B1, B2, B3, right? Just like not in some scrap.
Oh, we should series.
Oh. But I've never asked for Siri before. And was it B just because it was after A?
Yeah.
Oh, G. Yeah?
Yeah.
Alright. And yeah, so hopefully we could try and do some 2-day exam thing on the Saturday and Sunday. Leave the Monday, Tuesday for rest. Yeah. And similar here, like you might be able to do some take-home problem stuff on. It's hard to really know how, like what you can do right after, but you can definitely not do anything right before. Yeah. Okay, and then we have similar, and then we finish. Okay, so I've been doing some digging. Okay, and I found out where people get these selection school exams from. Okay, so that's why I was like, because I'm not just gonna give you India selection test, team selection test, like arbitrarily and hope it like represents. Yeah. And it turns out India did the same thing as basically every other country. And what they do He said take problems from the IMO shortlist. Yeah.
Yeah.
So if it's 2020, it'd be 2019. Yeah.
Yeah.
And 2019 doesn't come out until 2020 IMO. So no one knows about it. So it kind of works out. Yeah. And so that's kind of good for us because that means we don't have to kind of scramble. There's like 20 questions we should do to prepare, you know?
Yeah.
There's not like infinitely many questions. And it gives you some good idea because we're going to prepare for the IMO next anyway, right? It gives you some idea. Like they sort of have a little bit of a difficulty grading. So you'd expect them all to be like question 1 IMO difficulty. Yeah? Yeah, whatever that means, right? So you can kind of compare them with IMO difficulty, and therefore, when you look at the statistics for IMO, it actually gives you some insight into how people are doing this. Like, I mean, you know, like countries like the US. So apparently, China has the hardest TST out of everyone, and they can't use probably shortlist problems to separate everyone. And I guess they have quite a lot of exams too. So I know for a fact, like Britain uses that. You know, India, if you look at those tests, they do. Pretty much like all the countries with a reasonable population do.
Okay.
Okay.
So we do as well.
Pretty like if you look at that prep problem booklet you got, right?
Yeah.
So if you look at S3, okay. The S3 is shortlist 2014. Problem 1, yeah. S4, problem 1 is shortlist. Yeah. So yeah, like you can't guarantee we do on any given year. And it doesn't seem like every problem is from the shortlist. Maybe there was like a long list or something. I don't know. But it does kind of make sense because imagine if you were writing a question, right? You'd much rather submit it to the IMO than for the like anonymous TST, right?
Yeah.
And you get and once it's been submitted to the IMO, okay, you kind of get like a free shot at the TST anyway because it's confidential for a year.
Yeah.
So if you're gonna write like a reasonably difficult problem, you probably give the IMO a shot. If they put it on the shortlist and go back to TST. I don't know. So obviously this is all my speculation, okay, but it does make a bit of sense. And we'll know for sure once July comes. It's the shortlist at least. Okay. All right. So I mean, yeah, and I think it's important. I mean, it's like you shouldn't be intimidated by that. Okay. It should be like, okay, now we know where to look for the problems. I mean, just because it's IMO difficulty doesn't mean doesn't mean it's going to be beyond you. Okay. And if it's currently beyond you, it doesn't mean it'll be beyond you the next time you do it. That makes sense. You got to be kind of willing to try the hard problems. I was saying like everyone fails easy to medium problems before they succeed at hard problems, right? So you gotta have a go, and then you realize maybe like the next level up is not actually that far, Like once you get to it, you know what the distance is, So that's pretty important. So lots of shortlist problems, and so like and so basically, and I also want to say like the problems that you've already experienced have had difficulties that overlap well into these difficulty ranges, yeah. So like the APMOs that you just did, right? Like some of them would be harder than the first questions, definitely. Getting into the second question, right? And people who've done those like your kind of performance in the APMO, like this year, like in some years people have that performance and they get into the team, like that makes sense. So it's not like you already not only have you like should you try it, you've actually probably already done it in some settings, Okay. What else? Yeah, and like so the USTS TST problem. Like all the USTST is meant to be harder than this and the IMO. Yeah, according to they're like entrance ratings. Okay, but like the which is I think it's hard. It's a little bit harder than the US AMO, and then I didn't look at the US TST, but yeah, it should be harder still. But yeah, but even though they're harder, the ranges overlap as well, right? So the problem ones in the tests are usually not harder than problem threes in some other tests, you know. And if you're right, like AMO question 8 would still be quite difficult compared to these, yeah. All right. Yeah, so this links me into the attitude when we come preparing for this, yes? So yes, you don't have the best year to be getting in the team because you have like a year where like there've been a bunch of people who have already been in the team a few times, right? But I just want you to realize, I guess, see, like you're looking at yourself, so you don't really realize when you improve and stuff. So like the notions of people being better than you, yes. Notions of the problems being too hard, yes. They're not exactly well defined. Yeah, that makes sense. So that person might be better than you that day in some way. Like that problem might have also brought the best out of them and the worst out of you, right? But like you get better over time. Random stuff can happen to them. Yeah. So like they're in year 12, yeah. So like there's lots of things that could happen in year 12, you know. Probably the most important one is their parents just sabotaging. And everyone has parents. Yeah. So that's definitely a big factor. Some people just like focus on the HSC, right? You know what I mean? And then I guess some of yeah. So if you just name like 6 people, and they all have like I don't know pretty good reputations in this circle, you go, oh, they're all better than me. We're just gonna give up, yeah. But that's not like necessarily the case, yeah. And then the sort of the more ground you gain now, the less you have to gain next time. And so I mean, it's kind of funny. Like you have like trainee and contender, right? But I think once you're taking the test, you automatically become a contender, right? Maybe they have the terminology trainee and contender to kind of ease the pain when you don't get in or something like that. Yeah. Because maybe they even put that terminology there because they really rated the other people really strongly. Yeah, like, oh, 4 of them have already been in the team. How many people have already been in the team? 1, 2, 3, 4. If you count reserve. Yeah. 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 Maybe 5.
Oh, 5, yeah, if you count reserve.
Yeah.
Yeah. And
yeah, so I mean, you know, but then when they got into the team for the first time, you know, like they didn't necessarily do as well as you in the APMO. They didn't necessarily, you know, like it's all a bit random. But like, I think it's good either to believe that you're good enough to do it as long as you do your best, right? Or don't think about it and just focus on solving problems. Okay. Either way, I think it's more productive than like. There's no need to fear people or like think they're too good and stuff. Yeah. Because we've actually I've seen all their results in these statistics. Yeah. Like no one's deserving of the reputations they have. Okay. I mean, in terms like everyone's fallible. Yeah. I mean, obviously, like if you account for all that, they're still good. But it's like, you know, they're not going to be like 100%, 100% all the time. Yeah. Okay, so that's good. So with the papers, yeah, and obviously you don't need to solve all the problems. Yeah. Like I feel like you can still get 0 and 0 in the first week and have a chance. Yeah. It just might happen that way. Yeah. So like your questions might come in the second week. Yeah. So you know. It's like if the first question is like IMO 1 and IMO 4, right? Then like the whole team doesn't all get those questions, yeah. So like in the good year they get them all, 7. But like in some years, like those questions are actually pretty strong selectors of people. Like they determine 3 that get it and 3 that don't, even after the selection. right? So, there's a chance that if you just get like question 1 in all 4 tests, yeah, that'd be good enough. Okay? But so it's kind of it depends on other people and everything else. Um, yeah, and then the results that they have in the IMO are after they've trained. Yeah, so there's another training camp after the game. So yeah, so there's I guess 6 people that kind of stand out of your competition, and there's a whole bunch of other people, but I don't think it's really productive to worry about them too much. Just worry about the problem. When you solve it, they can't do anything about it. That's like they can't actually like scribble out your page or anything. Okay. And then with the prep problems, okay, so the prep problems we have in this list, yeah. So I think we might have to take another approach to it, yeah. So obviously, like the prep problems were intended for, like it's due on this Tuesday or something, right? So you're intended to actually, and the exams there are like way later, right? So
these are due during the exam period.
yeah, because they got handed to before the camp was cancelled.
Yeah, but that camp cancelled.
So that's why we can't like.
Yeah, that's such okay.
Yeah, so I reckon we shouldn't just take like the view shouldn't be like, well, that's a requirement, so I have to fulfill it no matter what. Yeah, adapting is the key to survival. Okay, so like it was obviously designed. In this situation, you lose at least 2 days to the exam, right? You probably lose like a few days before the exam, after the exam from rest, before that exam, right? It's like another 6 days difference, right? So like just because they need it, we shouldn't like it should be. The thing is for your benefit, it's not for their benefit, right? Like for their benefit is they cancel camp. That's for their benefit. For your benefit is you do these preparation problems. So if you do these preparation problems, I reckon do like a few under test conditions and like enough so that you're doing problems and it's helping you, right? But if it's really getting in the way of your preparing for the TST and stuff, like then it's not necessarily worth it. Okay. So one approach that might be fun is if we kind of team up. Okay. So obviously it's not like cheating. You actually acknowledge people that help you in the answer, right? So like thanks to Jordan for the main idea of this problem. Like I don't know, it's just stuff like that. And then that way you kind of at least get through all the questions and submit something, right? And maybe it's even more enjoyable. I don't know. Okay. But yeah, but I really do hope that we have a chance to prepare for this directly and looking at more of the 2018 problems. Yeah. Um, yeah. Yeah, because you could do it during Wednesday and Thursday. You could do one of these tests. It's like a selection test. It's a different deal. Yeah. So that would ease it a bit because it's five tests, right? S1 and S5. You're losing basically like half the time you have. So I don't think it's unreasonable to just sort of just think for your own benefit. Yeah, that's kind of. Anything else? Any questions? Seems like a reasonable plan. So basically, 2-day exam rest, 2-day exam rest, and then kind of do scattered problems. All right, which one do you want to do first? You want to go through Edwin's 2 or your 1 or 2 first?
It's all instant.
Huh?
I didn't see
Okay, yeah. Someone throw me the tissue box.
Is Edwin going to explain to you somehow?
Oh, I'll explain it for him. He sent it to me.
Oh.
Yeah. But it's actually so nice knowing it's high emotional boost.
Mhm.
Because
It's so much closer to the baby it is.
yeah,
Yeah.
that's one way to look at it too, yeah. And you kind of just realize how limited there are. Like it's not like people just like I mean the shortlist comes from 150 problems, but it's like it's still like functional equation, functional equation. You know what I mean? It's like, oh, well, we're getting there, you know? Yeah, but I bet you when you got that note saying you're a trainee, you never thought you'd do the exam, right? All right, so let's go through Edwin's solution. So question 2 in S2, yeah? 2000, I don't even know how to label it. 2015.
That's all we
Yeah.
usually S2, S2.
Okay, so the question was something like this. It was like you have A1, you have 2014 positive real numbers, yeah? And they're not integers. Yeah? And you want to show that there exists infinitely many. So what is that? There exists infinitely many n such that GCD this is the floor, right? Equals 1. Don't fuck me another blue. Okay. Yeah, I kind of already read it. So he said, assume that there's finitely many, yeah? So assume. So I guess let. So I guess the question doesn't quantify, but I guess it's saying for all possible 2014 numbers, there are infinitely many n duplexes, right? So I guess maybe assume for some AI satisfying these conditions, right? That it is only finitely many. Okay. And then he said, well, if that's the case, right, then there's only finitely many primes that could have GCD1. Yeah, so there's finitely many integers altogether. So therefore there's finitely many primes that have this property. Okay. So therefore finite many primes P satisfying GCD and equals 1. Yeah? Okay, and then this is where he uses like when you read this symbol, what does this symbol mean to you? Yeah, he uses it as since. So he always puts it like before the. So it's always like because. So it's always like because this, then this.
Yeah.
So I always think it's like the reason for the previous claim.
Yeah.
Yeah, so he goes, because there are infinitely many primes. Yeah, it's kind of confusing. But like, yeah, so I guess he's saying that there's finally many primes that satisfy this, right?
Yeah.
But since there's infinitely many primes, right, there must be infinitely many primes that satisfy um, GCD. So the GCD has to be 1 or P for prime, right? Huh?
For infinite, yeah. That becomes
These are all therefores. I'm afraid of the close symbol now.
that's a therefore.
Yeah. Yeah.
Oh, so yeah.
I feel like every time we've used there are infinitely many primes, there has been a way to avoid using that there are infinitely many primes. Yeah, I guess my attitude is every time you use something like infinitely many primes, like the proof lengthens by the proof of this claim, you know? Like it's kind of hidden in there.
Oh,
You know what I'm saying? So if there's a way to avoid it sort of easily, then I would take like the easy way to avoid it. But if there's not, I mean obviously we're trying to get to the truth. Okay. Okay, now he's saying if you look at the flaws are less. Let me just see this. If you look at the flaws, and also I guess you could even send an email to these people and ask them if they, you know, but you don't have to. I think you can just assume it's reasonable. You can just like, I wrote these answers. Oh, I didn't have time to do this, but this person helped me to make that clear. That's reasonable. Yeah. Maintains academic integrity, satisfies the conditions that they put on you for some reason. You have the feeling of finishing stuff. Okay, so P, what is it? P, it's AIP, yeah? The floor is less than AIP, is less than the floor AIP plus 1. No?
okay. So we got the first bit.
I mean, when I saw this, my first reaction was, why no equals something? But then he explains it in the brackets. Or it might not be an integer, but it could be like Q on T, you know? So he said in the explanation, it's like even if it was equal, it could only be equal finitely many times. Finitely many p. Does that make sense?
Volume. Is it finite or just one? Finite. Q on Q on.
K can be 0 as well.
It's K.
Yeah, what is K? He just sent me a message. I was like, don't worry. KP0. Oh, maybe we'll get up to that.
No, trick is that's the
Yeah. That kind of makes sense. Like that. Yeah. So something like
what's the second one?
the second one is just a floor thing.
So I think it's just because a floor plus one, like top. It also, yeah, my friend is four is also
Yeah. And it's strictly. Yeah.
so strictly for something.
Yeah.
I think for yeah, it's
Yeah. Okay. We'll see if we even need it. Rules is reason. He said, note that if the floor is equal, right? It's only possible finally many p. Otherwise, a1 p1 equals m1 a ai p1 equals m1 I p2 equals m2. Yeah, I guess there's not really anything to explain that, right? Because you would force the denominators of these AIs to be factors of p, right? So force them to be AI on something on p, yeah. They could all be on different p, but there's only 2014, right? Like it could be A1 on P1, right? Yeah. A2 on P2. Once you get to P like 2015, once you get past that, you can't cancel any of those, right? So we can find infinitely many P such that this is true. Okay, so then just do the sum, okay? So if you take the sum this, sum this, sum this, yeah, equal it. Then you get some multiple of P, right? KP. Oh, it was the
I see.
assumption. This-
I see. Okay.
He said this needed this. This L is meant to be the sum of the AIs. It's not an integer, yeah. And then this would be multiple. This same multiple of P, right? That's very good. Is there? That's looking pretty good so far. Um, then he says KP is less than LP. Okay. L equals K plus alpha. So L equals K plus alpha. That. Yeah, So I guess L is positive, yeah?
Yeah.
But K is not necessarily positive. K is probably positive. It could be 0.
Because all the AI are positive.
Yeah. So it's definitely, it's greater than or equal to 0, right? I don't know if you wrote this. And is it strictly bigger than 0?
So a version of 3.
Yeah, I guess you can take P large enough, it should be strictly bigger than 0. Yeah, you can pretty much get as big as you want, isn't it? This is getting close to the end. So if P was bigger than 2014 on alpha, yeah? Yeah.
It's after this. I think.
Alpha is like the difference between L and K. That's the reason you do that. Because then LP, right? Yeah, would be, it's equal to KP plus alpha P, right? But then alpha P is bigger than 2014. This would be greater than KP plus 2014. Yeah. Yeah. Would that be it? So P can't get Y. Okay, so do we even need the inequality strict?
Yeah, it's still not changing. It's still
Well, hold on. If this is so this is the key one, right? That one it doesn't matter.
Yeah.
Well, so like this one, because that's how you get the alpha, right? If alpha is 0, that doesn't work. Yeah. Now, what about the prime thing? Could you do this with powers of p instead of primes? Like you can have a fixed p and do powers of fixed p. Would that work?
I sort of think. I'm not really sure.
So if you had powers of p, right, the GCD would be some power of p. Yeah. But it would still be divisible by p, right?
Yeah.
So it'd still be some multiple of p. Yeah. And then that would still be the same multiple of p. Right?
Yeah. I think it should be.
Because I guess what I'm saying is it's more obvious that it's infinitely many powers at the same time. They're infinitely prime. So Is that inequality still hold?
Because of the biggest power is certain truth, which is has the power to go to
Oh yeah. Yeah, I guess that this one. Yeah, but I guess you need that to be like 2015 to comply. Like depending on the A, like if the A's that you started with just happens to be they're all over powers of P, then that would stop up. And then if they happen to be all powers of the same prime, on the denominator.
Yeah.
So you'd have to avoid all those denominators still. Mm. Yeah. I guess it's still probably better with infinite than prime. Yeah. So it looks solved. Then we overdo this.
Yes.
You know? Alright, what do you want to do now? 3 or 1? Well, you can try my units if you want. I give you units.
Yeah, sure.
I think it's good to try things. Okay, what was 3? What was 3? So question 3, yeah? Functional equation. So do they exist? That's a funny question. It's like, does that mean if you just find one, it's enough? F. So is there exist functions satisfying f of x plus like this y squared plus g of x? Is that it? And they're all reals, yeah? F of g. Do you guys try this at all? Huh?
I already tried that. Twice. Yeah, very good.
So this is awkward explaining this without having people try it. Yeah. Like every time I got some progress, I was like, should I just leave it like that? Alright, so oh yeah, Edwin asked if f is even. This is not so clear. Oh, okay, maybe let's see what hints I have for you. What hints I have for you. So you see that the range of f is greater than g. Huh? It's equal to the range of g. Yeah. Some hints. Okay, so this was already like annoying right off the bat because like I feel like subbing and stuff doesn't immediately satisfy like certainty. But that's not really that bad because that's how it is, right? Like you wanted to be able to sub in 0 and then conclude f of 0 equals 0. That'd be nice, right? It might not help you, but it feels nice. You want to put so I guess you try to put x and y equals 0.
Yeah. So apple
0. Oh, you put both of them equal 0. G of 0, yeah. Then you put 0, 1 at a time.
apple y.
Okay, so these are all helpful things. Okay, and then
apple x plus apple y. So that's what I'm doing.
yeah. So this is interesting, but now the ranges are equal. Yeah? Actually, it's actually not a natural thing to conclude, okay? Because you're like, well, f and g are the same, basically, right? So I guess you're just like, well, you're not really thinking about the ranges. You're just thinking they're the same, yeah. So you're kind of just like, let me just get rid of g, yeah. Like they're just the translates of each other. Yeah?
I think
F injective.
try or I mean injective or like positive. Maybe something f of y like f of a
Yeah.
then f of x plus f of a is equal to
Oh,
a squared.
okay. So basically, it's like plus or minus injective. Is that what you're saying? Yeah, like if f of a equals f of this, f of b, is f of b, yeah. Then this, then u squared equals v squared.
Something y. So it's like v is
Y equals 1. Yeah. Yeah. Basically injective. Which means the same is true for G, right? Well, like 2 to 1, possibly 2 to 1.
is equal to equal to 7 x. It's equals to transactions.
Yeah, this is why Edwin asked if f was even. Yeah. Oh, and so what you were saying before about it, like the range is sort of bigger than G, right? So I guess one way to sort of say something along those lines, like the range is connected. Yeah. So if anything that's in the range, right, you get everything on purpose. Yeah. You can make Y go like that. Positive as high as you want. So anything else interesting? Yeah. This, right? You might want to rewrite everything in terms of F only. That could be done. So the original equation becomes f of x plus f of y equals y squared plus like f of something, x plus f of 0. Yeah?
Now you show me y is
Uh,
right. You show me y is
yeah.
right.
Right.
Yes. Right. You show y is okay.
Yeah, like you can't get anything from this, because that's how you got that.
Yeah.
Yeah, so some of these things become like f of y equals y squared plus f of 0. Yeah? And this, it's another one. Yeah. Some other things I tried subbing in was making this 0. So x equals minus f of y. Then you get f of 0 equals
squared plus minus minus.
you know. And then I guess that could also be y squared plus f of that, yeah. I went on a bit of a detour at some point. I don't know if you weren't interested in the detour. There are some points I could do. So I guess another thing you could try is, because of this, right? You can sub in, you can replace y by f of y. Yeah. Replace y by f of y. So you get y squared plus f of f0, right? Y squared.
Oh, it's the y. I thought f of y is equal to p of 0, and p of 0 is equal to
Yeah. Okay. I mean, at this point, I went on a bit of a detour because I was like, this equation has too many of these f of 0 in it. This might not be an exam move, but oh, it's f of 0 minus x plus x plus x.
where you can put in the bottom
Mm-hmm.
and something y is negative
Yeah.
1. You get f of the y squared stays the same, but then inside you actually have f of 0 minus f of negative y.
Uh-huh.
And you know that where so we have like f of so we can equate those. We have f of 0 minus f of y is equal to f of 0 minus f of y.
Kind of, what were you saying? So you have,
So you do something y goes negative 1.
yeah.
Yeah.
Mm-hmm.
And then you can equate them because the left hand side is the same.
Mm-hmm.
And then you get rid of the y squared.
So you equate these two.
Yeah.
Okay.
And then since we have indexed positive and negative, we can do
Uh-huh.
where f of so it's either f of 0 minus f of y is equal to f of 0 minus f of negative y.
Oh, okay. So either f of 0 minus f of y is equal to f of 0 minus f of minus y, yeah? Or
f of
the other way.
Yeah. And then so it's either f of y is equal to f of negative it's either or it's f of y plus f of negative y is equal to 2 f of y.
So either they sum to 2 negative f of 0,
Yeah.
2 f of 0,
Or they are or
yeah, for every point. Yeah. So it's kind of like f of y equals plus or minus f of minus y. All this stuff is 0. So I went on a bit of a detour where I set all these things to 0. Yeah. So I was hoping I could see something. So if you set everything to 0, okay. Erase some stuff. So if you set everything to 0, can you see that you get? So this is what inspired me to do it. You have f of x plus y squared, right?
Yeah.
Equals f of y squared plus g of f of x. So actually, f of x equals g of x. Can you see that?
right, are you assuming f of 0 is 0?
Yeah. So let's assume f of 0 equals 0. Yeah. So then f of x equals g of x. Yeah. And can you see that?
In that case, I think.
No, I don't know. Yeah, at the start, at some point at the start, I checked all the straight lines of mx plus b stuff.
Yeah.
I don't think they work. Okay. F yeah. So here, do you see that f of y squared equals f of y whole squared? Not it's put x equals 0.
Yeah.
Okay. So this is like
And then you can put the 2 y squared,
yeah.
and then you have it up.
Yeah, you kind of have Cauchy, right? This is kind of the point of my thesis. Yeah? Do you have exactly Cauchy, or what do you have? It's like Cauchy with a positive.
What do you say?
So you just put that into there.
Yeah.
It's additive, right?
Yeah.
So it's funny, it's like it's additive if you assume the second thing is positive, the first thing is whatever, yeah? But because it doesn't matter what order you add, right? That means you can also do it with the first thing is positive and the second thing is negative.
So I need one of them positive.
Yeah,
But if they're both negative,
you can still do it, I think. Yeah. So I think this implies coach.
yeah, how do you do it?
Alright, let's have a look. So if you have like, so f of 0 is 0, right?
Yeah.
So you can set x equal to minus y squared.
Okay.
So 0 equals f of y squared plus f of minus y squared, right?
Yeah.
That means f of minus y squared is equal to minus f of y squared, right?
So
if they're both negative, right?
Yeah.
Then you just make it negative y squared, right? And then it becomes negative and positive.
Yeah, so once based on that, once you get on, then you can do the end. Because from that you get that on, which means that you can't still apply for negative.
Yeah. Yeah, so if you have like two negatives, right?
Yeah.
You just take the negative sign out.
Yeah.
And it becomes a positive. Yeah. So this is a negative, yeah. Every negative can be written like that.
Yeah.
And so then you can always write it as a positive with the negative sign in the front.
Yeah.
And then the positive just splits off.
Splits off and then you put the one bracket.
Yeah.
Okay.
How do we so we get that result, how do we put that into
So like if you have like let y squared be like a equals b, and then negative y squared equals negative f of a, like negative f of y squared is negative f of a. Minus if they're both negative, you take out you take out the negative, and now the inside positive, so you can do the same.
So this is equal to negative f of negative x plus minus y, right?
Yeah.
Which is equal to negative f of minus x plus f of minus y, yeah? And then
f of x plus f of y.
Yeah.
So you have this one. The f of negative, yeah.
You know?
Yeah.
So it was Cauchy. And for some reason I kept thinking of that stupid lemma that I didn't even know how to prove. It was like the dense thing that we did. I guess we never tried to prove it, that's why. But it was like at the top of my mind for this or something. Okay, so
it's even and
yeah,
with the f of x equals 0.
yeah. Like from this, right? It's kind of like saying that f has positive image. Like if g of 0 is 0, it's like saying f is always positive. You know? So it's like, so if you think of that dense thing, right? It can't be true if it's always positive.
Yeah.
Right?
Yeah.
So then it has to be kx.
Yeah.
Yeah? But then kx doesn't work. Yeah.
So f of 0 does not.
Yeah. So that definitely contributed, even though it never got written down. Right?
Yeah.
But maybe if you want to write something down, you could think of it like this. So f seems to be onto.
Yeah.
Is it onto?
Sort of.
So if g is 0, right? So we're talking about the green now still, yeah? So if g is 0, because g of 0 is 0, yeah?
Yeah.
Because f of 0 is 0. Yeah. So f at least outputs all the positive numbers. Yeah?
Yeah.
But then we said that f is kind of odd. Yeah.
Yeah.
So should output all the negative numbers too? So it's onto.
Yeah.
Yeah.
Okay.
But see, no matter how onto it is, it's a problem, okay? Because if it's onto, they should get everything here, right?
Yeah.
But that's telling you f of everything here is positive.
Yeah. Oh, so
Yeah.
Yeah.
So there's some problem with the positiveness. Yeah. So I guess this was the point. Maybe I can't remember now. I can't remember what happened now. For some reason, I've blanks these days. But like, this was like the point where I was like, oh, okay, there shouldn't exist f or g. Oh, yeah. It's kind of like they probably don't exist. Yeah. Whereas I think if you're experienced, you're probably like, let's prove that they don't exist right at the beginning.
Yeah.
Cynical.
It's about the flow.
Yeah. And if it did exist, it'd be too trivial, I guess.
Yeah. This one's an obscure version. It's what they have to.
Okay, so where are we in the storyline? Okay, so that was R2, okay? Now we'll go to R3, which is kind of just like revisiting R1. Okay, so I decided to use algebra. So algebra means let f of 0 be A. Another blue. Oh, there we go. F of 0 is A, yeah? Is A, and then G of 0 I let be B. Okay.
So f of a equals b.
F of A equals B, yeah? Alright. Because these seem to be now the main characters. Right? Because if they're equal to 0, then you're done, right?
Yeah.
Okay. So I guess this is now A, right? A. This is equal to y squared plus b. Yeah? Alright. Can you see that? Kind of like we're kind of inspired by the onto, yeah. So we're trying to see if f is onto. Okay. So I guess the first interesting thing in that direction is this line here, right? Because that's telling you the image contains it's basically the interval from B onwards, yeah? Yeah. Okay, well that's okay, right? That's just an observation. But then when you mix it with this observation, okay, that's when something breaks. So this is something I didn't even really check, but I feel like it has to break here. That's the feeling. Okay? So once you see this, okay, it's G's got the same image as F, right?
Oh, yeah.
And this is saying the opposite things of this, okay? It's saying that the image of G goes from A backwards.
Oh, yeah.
Yeah? The image of G contains like this, yeah? Edwin says, can you switch from green, please? So, Yes, it happened. Green looks really good live, but it doesn't record well, I guess. Does that give you that feeling too when you see the image of G contains the wrong interval?
Yeah. And now you have like it has to be between A and B.
Yeah. So I was like, should I even keep going? Should I just leave it at this point? So the image of F, right, contains minus infinity to A, right?
Yeah.
You see, you can assume that. So
That's the image of B.
they're the same.
Yeah.
They're the same, right? What's this? So this observation I never made at the start. Actually, I should make that point. I made this observation at the end because this is such a special case of the fact that they're basically equal that it's hard to observe it, right? Here, so the image contains these two intervals, right? The union.
But then we said that like the range of f of y is bigger than like is from greater than or equal to b. But then the range of it also has to be less than or equal to a.
So it's between.
So the image of f is from b to positive infinity.
It contains
Yeah.
B to positive.
And then the image of g.
The image of G contains
contains
minus infinity to A. Yeah.
So the image of F has to be
So the big
greater than B, but it also has to be smaller than.
So basically, I guess at this point you may as well assume A is less than B. Yeah. Wait. So do you understand why this is in the image? So if two sets are in the image, then the union is in the image too.
But it has to be because when we have f of y, so
Yeah.
the image of y has to be greater than or equal to greater than or equal to b.
Yeah, it has to contain all the numbers B and above. Yeah.
Isn't that only those numbers?
Well, we don't know. Like it could be this might not get all of the things that it could input, right? So like if this could only this is only positive, then the negative stuff might give you other stuff. Yeah.
But doesn't the negative stuff? The negative stuff would be the same as y squared.
Oh no, I mean like this thing.
Oh, yeah.
This thing. So like yeah, so basically yeah, you're right. So if F was onto, right, then this is already a contradiction. Yeah. That makes sense?
Yeah.
Because if F is onto, then it's saying it can only give you stuff above B, right?
Yeah.
But this is saying you can get anything as low as you want. Yeah? So that's why you can assume basically A is less than B, yeah? Because if they are overlapping, then all F is onto.
Yeah. And then if it's onto, then
If it's onto, then what you're saying is true, right? Because if it's onto, then you can get every real number here, right?
yeah.
Then everything output by this is the image.
Yeah. Oh, and then it's not.
So then the image is all the B, right?
Okay.
That makes sense.
Oh, yeah, this is really teaching things now. That basic common.
Okay, so I guess
This is in physics and natural physics.
this is really compelling. Okay, this is like something's gonna be wrong. Okay, so maybe something you could try is actually just unravel some of the things. Like G is, we know exactly how G is related to F. Yeah, so we're gonna put that back in. So if you put G back in, you get F of it's A, right? That's what that is. Right?
Yeah.
Oh, then I put G F back in. Yeah, and I guess one of the other incentives for you to do the exams and hand them in and stuff is when you brought them to the camp, you'd be able to go through it. But that's no longer an option. Okay, so is that true?
Yeah. Well, something like zero.
Yeah, so if you sub in y as 0, you get f of 0, right? This will give you a, right?
Yeah.
That's a good idea. So basically, if you sub in the numbers,
Right, no, didn't we? That's really
That's
silly.
the definition of it.
yeah.
Yeah, okay.
No, that's not bad. I mean, look, so basically, you can just sub in stuff that you know is in the range, right?
Yeah.
So that's kind of useful. So like for example, if you sub in this bit, right?
Mhm.
So that's like when you said sub y equals 0. It's the same kind of thing, yeah.
Mhm.
So that end up getting a here, right?
Yeah.
You get 0, yeah.
Mhm. Yeah.
As you keep getting more negative, right? This will get more positive, yeah. So when this ranges through all these values, yeah, then this f whole thing outputs 0 to infinity, yeah. Is that true?
Right, yeah, it's, yeah. Are you changing y seed ranges, putting everything from 0 to
Yeah, so yeah, we're putting the values of y that gives you all these values in this first part of the interface. Yeah,
So,
this is kind of just like testing it out.
so
So when you put the a in, you get the 0, right?
you get smaller a minus of 1.
So the values that come out of here is basically 0 to infinity, right? And then you're taking the f of it. Yeah.
And then so yeah. Okay, so f
Yeah.
of a really big number.
Yeah.
It's small. It's really negative.
So I mean, the point is, once you take f of like this interval, right? Like once you take look at just the parts that's bigger than b, right?
Yeah.
Yeah. Okay. Once you get past bigger than b, what am I doing? Where's b? Yeah. So where is f taking this whole interval, right? It's taking it to stuff that's a minus y squared, right? Yeah.
So
So it's taking that interval into this interval, yeah?
Yeah.
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 So f is mapping this interval into this interval. You know? This is the problem that's growing.
Yeah, it's mapping stuff into well and that's sometimes we like a cell. Like there's a point inside where maps do that between 0 and 8.
Yeah. Oh, we don't know if A is positive, but yeah, like if A was positive, yeah, it's mapping stuff in the other interval. Let's say about this. So here it seems like, okay, maybe this is what I was thinking. So if you have f of y here, right?
Mm-hmm.
Everything like in the image, right, has to map. This is getting too complicated what I'm saying. Well, like everything that this comes out of here, right, has to then get mapped into B to infinity, right?
Yeah. Oh.
Yeah.
Yeah.
So everything that comes out of Y, right?
Yeah.
Has to then get mapped into B to infinity.
Okay. Oh wait, doesn't that defeat both of the other things?
Yeah. So yeah, that's right. You're right. So that's right. That contains all this, right?
Mhm.
Yeah. So all of this must map to B to infinity, right?
Yeah.
Right?
Yeah.
Because everything in the image, right,
Yeah.
maps to y squared plus b.
Okay.
Yeah?
Everything.
So everything in the image maps to y squared plus b. Yeah?
Yeah.
Okay, so that includes this. Yeah?
Yeah. Well, yeah.
Well, that includes all the stuff past some point, like some really big number. Yeah? All the big stuff gets past, maps to stuff bigger than b. Yeah? Right? Because everything in the range of y, f, yeah, maps bigger than b. Yeah?
Yeah. Yeah.
Right? So everything in the range maps bigger than b, yeah? But this, okay, is not mapping bigger than b.
Yeah.
Yeah?
Oh.
And it has an intersection with the range.
Yeah.
Or anything bigger than b, right? It's going to infinity.
Oh.
That makes sense.
Yeah. Okay. Oh, I guess we can also use the
I'm showing you the dirty, genuine answer. So clean it up. Feel free to clean it up.
Yeah.
You understand what I'm saying?
Yeah.
But it's not like, it's not like planned. It's more like once you know these images are backwards, something's wrong, right?
Yeah.
And then I guess I'm calculating the only things you can calculate. Like I'm just going by the definitions of stuff, yeah?
Mm-hmm.
Yeah, so everything in the image of F has to go bigger than B. Yeah?
Yeah.
B is in the
And
image of F.
anything that's bigger than B can be right.
Yeah.
Anything bigger than B can be gotten by something in B.
Yeah. And then we just showed all those things mapped to something less than A.
Yeah.
Yeah.
That's bad.
That's bad, unless A is bigger than B, right?
Yeah. And then A is bigger than B.
That's on to it. Yeah. I guess this is an example where it's like, maybe this is helpful for you guys because this is like everything you make, every progress here feels like nothing.
Yeah.
Yeah. It's like, oh, the images are equal. Who cares, right? So you're like, okay, nothing cares. After all this time, I got nothing. So let's just give up. Yeah. But then, but you realize the next nothing solves the problem. So like these nothings are actually adding up to something. Yeah. And actually, if you kind of experience, it probably wouldn't even take that long, right? Yeah. Because the range observation was available actually on the first run, except I just took a detour for like maybe no reason. Yeah? Yeah, I think that will come out of your thing as well. Yeah. Yeah. Because this is saying that. This is basically saying something like along the lines of either the images are negative of each other or they're equal.
Yeah.
Alright, so we could do this one? Yeah. Alright. Yeah.
Just do
Yeah, let's do one. Do you want to draw the diagram up before I start recording?
yeah, there's a lot of lines.
Yeah, so this Cauchy thing never came into it.
Mm-hmm.
So would the question have been slightly more interesting if we just assumed that G of 0 was 0 or F of 0 was 0? Like, as a question.
Oh. Yeah.
But I guess the Cauchy thing never came into that either. It was just sort of, it kind of just helped you convince yourself that it was true. Yeah? Like, and then the proof used other reasons that were probably more obvious.
Which symbol triangle?
Which symbol triangle? I started with. Have you found like QBN and BEN?
QB and what?
QBM and BEM.
Oh, Joe, do you mind if I just record you explaining the answer, and I'll kind of
Yeah, that's
ask questions? And if it doesn't work out, you can always demand to delete it. It's
okay.
it's deleteable. Though the stream is going to be like different way of deleting.
Mm-hmm.
So Edwin should be like Edwin's on the stream right now.
Okay. Or we could also have like CDM and C.
Where's the?
Huh?
Oh, where's the? Yeah.
These just
C and
CDM and CPM. They're basically like symmetrical pairs.
CPM. Great.
Which one do you have?
C.
Yeah.
CP and
CDM and CPM.
CPM.
Oh, so it's just interrupted this.
Yeah.
Messy. And then that led into another set of single triangles.
So we just back it up. That's what I do.
Essentially, yeah.
Is that recording? I can start recording. Yeah. Okay, so this is question 1S2, yeah?
Yeah. Okay.
Oh, this is diagrams are better than mine already. This is so you know, there are like younger students that need to be taught geometry properly. Cough, John Waffle, cough.
Okay. Lines.
Oh my god.
Design. Okay. Wait, no, 4 lines. Okay.
Yeah, straight lines.
Somewhat, no, not really.
Oh, some other color.
We need BP and CP.
B, B, C, Q. No.
Okay, so I is the incenter.
Yep, I
M is the midpoint of BC.
So that's just like
The minor arc, is it? Yeah.
Yeah, and it cuts the circumcenter circle at that because that's just chosen. Yeah.
And then there's a circle going through I and M.
Yeah.
That cuts
at D and E.
Cuts at D and E.
And you prove that like PQ goes through a fixed point.
So PQ is going from ME and MD, right?
Yeah.
And then PQ, you're basically trying to show that PQ goes through I.
Yeah.
No matter where D and E are.
Yeah. So essentially I just started by changing up the coordinate. I thought it was easier to prove that something was cyclic rather than something that was fastest for a point. So I started with PQ.
Mm-hmm.
So basically means that if you had a line
going through I
that intersects the circumcircle at P and Q, and then you draw P and QM, they cut the line BC at D and E, you would have that I, D, and E cyclic. Yeah.
Oh, yeah. And wait, so if I, D,
And
E is cyclic, is that imply M is cyclic with that?
ID and E is
Oh, the 4 points is cyclic.
Yeah.
Okay.
Yeah, so that's just rephrasing the problem really. And then I started by just tracing on a few angles. So this happens to be alpha alpha. Well, I used theta and phi, but like you could use theta down. Okay, so I need these ones. Okay. Oh,
Actually, using zero colors makes you
unable to do it with one color after the other. Have you noticed?
Yeah.
So I can't even tell where
There's black and green.
green apparently is not good for Edwin, so there's black.
Okay. Cool. That sounds. Changed colors of these angles. Alpha can be good.
Like the beauty of the colors, you can make it even now. That's how
I will find you there.
these are being donated to somewhere else.
Right.
I want the black.
Fancy.
Black.
Black seems sort of busy.
That's this one.
One's getting less every time. Oh, that's better. Yeah. Okay. So let's go with this.
That's it.
Okay. So essentially, I wanted to use bow tie to prove it.
Mm-hmm.
That is a whiteboard marker, right?
Yeah. Yes. So I tested some angles. I found this was 5, so this would also be 5.
Mhm.
Yeah, bow tie. And then because this is alpha, we'll get that, and MCB is alpha. It's alpha over here. Yeah. And then we get our first angle that's like inside the thing we want to prove that's cyclic, so this will be alpha plus 5. Because, yeah, external. So ideally, when we prove that this would be alpha plus 5, right?
Mm-hmm.
So, yeah, go from here. And I just sorted it the same thing on the other side. So, this is theta, this would be theta.
Oh yeah, it's good to do things on
Yeah.
both sides.
It's sort of symmetrical, so this proof can go. Maybe. This would be
Oh,
alpha theta plus theta. And then a bit more. Find that MPC is MAC, so this would be alpha. And then also that
mm-hmm.
QAC would be equal to QPC.
QPC.
Yeah.
QAC. Yeah, 5.
So it's 5. Yeah. And then on the other side again, we get that PQM is equals to PAM.
Theta plus alpha. Yeah.
So it's alpha plus theta. I didn't draw QB, so this one.
Oh, is the black doesn't work?
Yeah, let's listen to that one. Okay, so from here I found we have like quite a few similar triangles. We have like DME. We have DME is similar to QMP, but we also have that. I went with QBM. QB. Oh, I didn't draw that. Okay, I'll do that one. I went with. Well, I didn't go with. I went with like PCN. PCN.
Yeah, so alpha.
So there's alpha here. This would be alpha plus alpha. This would be a theta. Yeah, because that equals to PAB.
Yeah.
So this is alpha plus theta. That's alpha. And then we have here that this is alpha plus theta. This is alpha. Yeah. Yeah. So we have that PCM is similar to CDM.
Oh, okay. Wait.
Yeah.
Yeah, two angles, yeah.
CDM. Yeah. So then we get a bunch of side ratios.
Oh,
We get that. Well, not a bunch. Well, we get a bunch Chinese. So we get that Q and on BM equals to BM on BM. Yeah.
okay. So QM is opposite alpha plus phi, right? Wait. So
Oh, this
Wait,
one.
this is the
other triangle.
PCM.
Huh?
Wait,
I think you did another triangle.
the other.
Oh, whoops. Yeah, I'm copying down from the proof. Right. Ah, so that.
The change the Q to P and
Huh?
change Q to P.
Oh, right. Yeah, yeah. I have to. Oh. Wait, what would be?
So PM.
PM. Ah, PM. So PM. What about
It's
this?
PCM, right? So it's
So
PCM is opposite alpha plus theta.
Yep, PCM.
And then what's the other triangle?
PM and CM. That's right.
CM. Yeah, that's opposite alpha plus.
The one opposite alpha, so CM. Oh, yeah.
Hold on a second.
Yeah.
Okay, that's the big triangle, yeah, opposite alpha.
Yeah.
CM on. Yeah, okay, cool.
And now I just use Charles lemma, so I can PM on IM equals to IM on DM. Right? So that's a P.
So CM is equal to IM, is what you're saying?
Yep, CM equals to IM. And that's just Charles lemma.
CM. You said Charles?
Yeah,
Like
Charles lemma.
Name? Is someone's name?
Yes, his name.
How do you spell it? Charles?
Yeah.
Or is it Charles?
CHARLES.
Oh, I didn't know it had a name.
Well, in the Australian
It seems like
Indian
it's his
community.
first name. His last name.
Yeah.
It's made by a guy called Charles.
Apparently some dude called
Yes.
Yes. This is Australian. But yeah,
So
essentially.
they done it.
Yes.
Yeah.
Well, if you look at the sides, you have PM here, you have IM here, IM, DM. Yeah.
Oh, so, yeah. Is this power of a point or something?
Oh, well, it looked like alpha point. But
PM. Where's PM again? PM.
DM,
On IM.
IM, and DM. Yeah. So you have these two triangles are similar. So you have that triangle E and I similar to triangle
IDM.
I and D. Yeah. Yeah. So that implies that angle MPI equals to angle DIM. No, M, right, MID.
Yep.
Yeah.
MID is equal to alpha plus phi, is that what you're saying?
Yeah, equals to alpha plus phi. That's right, but it's fine with that. So we have DIM equals to DIM. Okay. We good? Yeah.
Would you do the first time?
Huh?
The
First time, I
You probably
used,
just did the
I
same
used
thing but
these two
forgot what you did.
sets. I used these two sets of similar triangles and it proves that a quadrilateral is cyclic because it was.
Yes, sir.
Yeah.
I have that.
Good stuff.
PM on IM. We're trying to do PMI. Okay. PMI. Similar triangle IMD.
IMD because the angle at M is common.
So the angle is common and you're doing SAS.
Yeah. SAS.
So PM, the big triangle is PM. Oh, but it's
Yeah.
switched.
It's
Okay, so the big triangle, big one on the IM is equal to the big IM and the DM. Oh, it is.
Yeah.
Okay, and then what's the
So get that you have photons.
so is the angle. So
So you
So then this-
EM.
so this angle is the obtuse one corresponds to that one, right? And this angle corresponds to this
that
one. So it's alpha plus phi, yeah?
That's fine.
Okay, and then alpha plus phi is equal to alpha
Yeah.
plus phi.
Yeah.
So
That's
that's like the second.
Oh,
Yeah.
And then of course you can reverse it for the other angle because it's the same thing.
This whole time PC with instruction.
Or QB.
it can't be too PC.
It's a contract I didn't want to make because
Yeah, because it like went through like 50 months. But
Oh, you had to. Oh, P was not originally connected to C.
well, none of like half these lines were connected.
yeah. You can
Oh,
do
But
that
and
one
PC was
once.
the one I didn't want to connect because it was real messy.
Yeah, because the other ones are all outside. But
Yeah,
Maybe that was the point of the problem.
Maybe.
It's like
Challenge-
let's draw a
challenge
diagram,
yourself.
okay, and then remove the line and make sure no one wants to draw that line.
What Edwin said. Edwin said.
It's like, OMG, I tried to bash them, got 50 variables.
What?
No,
Oh, no, that's you. That's a joke. I'll stop that right there. It's still live, but so. Yeah. Any questions, bruh? I don't speak like that. But anonymously online, who knows how I speak?
The thing is like so the Empire State Building needs and it had a valve had something broken. So they got a guy to come and fix it, and the guy gets his wrench and then just smacks a valve, and then suddenly everything's running again. And then he's like, that'll be $5,000. He's like, well, it takes $5,000 to smack a valve. He's like, no, $5 to smack a valve, $4,995 to know which one to smack. It was like this.
essentially. You draw a line, and then hold on.
And
it's
you just know which
triangle to use. Yeah.
And don't like too many to use.
Yeah, there's a ton of symmetry.
Yeah, I try to use the MDI,
MDI.
and the hang on.
MDI is one use.
Yeah, and I tried, and then I worked out like other stuff.
MDA and MDI.
Oh, MDE.
That was the one I think first.
Okay. No, I did like
It's like, oh, here the problem is done. It's like, oh, okay, how much? $5,000. $5,000 to chase 400 angles.
It's Chesapeake.
Oh, okay, you have it.
yeah.
Oh, yeah.
It's like $4,995 to chase it. $5. Oh, it's just $5,000. Give me $5,000.
Okay. It's time.
4:30. Oh, would you believe? Let me check what time the dinner is.
Like Bitcoin token 9, crazy as they
There's many. I can't even have quit the city. You can explore in 50 texts in the first time.
Yeah, so can we just have a quick checklist through? Okay. I'm pretty sure. Oh, actually, what's his name? Edwin wanted to go through S1 question 1.
That's one question. It can't be yet.
We haven't
Oh, that
done
one. You just.
it. But does that mean? I forgot about that one.
That is interesting.
Alright,
Yeah, so can we just kind of quickly?
wait,
Starts with words.
it's kind of stupid. Starts with shields.
It's just like.
So with the test, right? So we just did S2, yeah. So they're all done, yeah.
Yeah.
That's kind of dodgy.
Oh, AMO is pretty.
We did all S2, yeah.
Sometimes. Yeah.
Okay, so if you look at S3, I'm pretty sure the problem 1 is a short list problem.
Oh,
Yes.
I'm a short list. It's either 2014 or 2015. If you want to make a note on your page. Because those ones, there are solutions for those ones. So
No. So this one, shortlist. Yeah.
So I guess that at least says that out of the 3 selection tests, question 1 has come from a shortlist. Like twice at least. Yeah, I guess I never looked at the shortlist close enough to verify exactly all 12 poems came from.
Open 2 of S. Reason.
Well,
It's short.
Yeah.
I mean, there should
This
be.
looks like a
So,
variation.
okay, so another thing is, I reckon for Jordan, you should pick an S test, right?
Yeah.
Maybe pick 2 of them. Hopefully that you haven't tried any poems on.
Yeah.
And do them Wednesday and Thursday. Yeah.
Okay.
Basically, if only you could just take time off school just do it.
Yeah.
But I guess like
Like
maybe in the evening or something.
Yeah. Okay.
Or you can even start on Tuesday.
Oh, sports. Yeah.
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 I don't know, but like you can try them on time conditions. That way,
You-
you get the most value out of the questions.
Yeah.
Any people.
Wait, do you have to do F1 as well?
The
no.
F's are
The F's are the
F's
opposite.
are Q's.
F is like July, yeah.
Because those are the hard ones. What do you think? Maybe. Oh. Interesting.
Which one do we try?
So which one is
It's very fun, isn't it?
let's see, try the screen this time. You can do something.
Did you already do S1?
S1?
How many of S1 did you do?
This one, I've looked at 1 and 3, but I've actually solved it. I've added yeah.
You want to brainstorm 1 then? Because
Yeah.
Edwin said something about 1.
Sure. Yeah, one looks interesting.
Right, I think there is one around.
It would be like 2 times since you can build around.
Alright, erase.
Nice.
Well done.
Yeah.
Yeah, I think next time we draw that diagram or something similar, we'll draw like that line PC in like red or something, or black, or some like emphatic color.
Yeah. It's like,
Because that's kind of key. That was key to the poem.
Yeah.
Hey, look, we found someone.
Oh,
We found Imaji.
Imaji.
Do we kill it?
Imaji dies pretty. Well, he might not.
I'm pretty sure he does. Yeah.
They tend to build a lot of riders and stuff as well.
Oh, do we hit him?
Maybe you won't show him. I don't know if you
Let me just-
do it what the hitting because we have rooms there. We do that.
You can just stuff.
Yeah, okay.
Oh, he won't show him.
Oh, hey,
still
we- Wait.
Huh?
That's like bottom.
Yeah. You one shot minus, which is good.
Do we rush it out right now or do we go for
I'll just go and
No,
let's see
what's
what's going on.
Oh, and then we just. Oh, wait.
No, that's defending. It has a shield because it's in the city. You can't one shot him.
Oh, wait, what's the shield do?
The shield will number for yourself.
Oh, okay. No, oh, then no one that can kill.
Yeah.
Alright, we just do this and then
And
go
go
the
to
right.
city.
We go the right up.
Yeah.
And then run that way.
Oh,
Why is it? Oh, okay, well, we just have to that way.
no, it's Belarus.
Alright,
Belarus is a pain to kill.
what do we do? We just kill this. Oh, we get a veteran.
Wait, no. Get your right to kill him because he has to help.
Okay. So,
And then you can grab the room so it can go up.
I mean, because I want ruins, right? And then that's probably just water.
Yeah. Oh, you can't build him as well. That's the problem.
Yeah. And he's gonna like kill me. Okay, so I have to move my dude here. Because I need to make sure this guy dies before he takes my city.
That is true.
Okay, I'll move my rider back here. I'll move my rider on here.
No, you can, I think you can maybe grab wolves.
And then what about this guy? Move it back. Yeah. And
Ugh.
1, 2, 1. We can have one. I snap.
Yeah.
Alright.
Yeah.
Oh, this one.
Okay, let's brainstorm S1 Q1, yeah?
Oh, someone's getting snapped over here.
You notice if you say brainstorm, there's no pressure to actually solve it.
Yes.
So
don't worry.
It's almost like the only pressure is to have fun.
Okay.
Yeah, so n is greater than or equal to 2 is an integer, and you have an n by n chessboard. Okay?
Mm.
It's not quite a chessboard, I guess, but yeah. It's I guess it's the chessboard going to help you understand what an n by n grid is on.
Yeah.
Indeed.
Okay, let's do n equals 2.
Schematic.
We have the 2 by 2 grid, yeah?
Oh, yeah.
And
So,
you want a configuration of rooks.
well, I think there's only 2 configs.
It's peaceful. Right? If it's peaceful, if every row and every column contains exactly one rook. I feel like we've seen something like this before. Have you seen something like this before?
This was like similar to a BMO, I think.
Oh,
So it's peaceful if it has rooks.
Sort of.
Every column contains exactly one rook. So it's like one of those permutation matrices.
Yeah. Okay. Yeah.
Mm.
Oh yeah.
Every column, every row contains exactly. Are you talking to me or?
Try small cases is small mathematics.
Yeah.
What?
Try small cases for this problem.
Yeah.
I don't even know what the problem says at the moment. Okay, so it's peaceful. This is peaceful, I
I
guess.
need to log on the city.
So this is peaceful, yeah?
Yeah. I think there's only 2. It's like that and the other one.
Yeah, yeah. So I guess they're not attacking each other. That's why they're trying to make it peaceful, right?
Yeah. It's like just me.
The D denote the set of unit squares on the diagonal that run from the bottom left to the top right.
I think you want
That A, oh man, the question keeps going.
to skip it.
That A denote the set of unit squares that lie strictly above D. So what's D?
D is
So
bottom left
this
to
is
top
0,
right.
0.
Yeah, so it'd be like
this is
1, 2.
Yeah. So it's
1,
in
2, 1, 2. So what's D? D is equal to
Y, X, and X or something.
X or Y.
Coordinates A.
from bottom left to top right. So
Yeah.
it's 1, 1, 2, 2. Is that right?
Sure, recover.
Oh, so it's not the usual diagonal.
Well, I mean, it doesn't really make a difference.
Oh,
Yeah. That's what people
That A denote the set of unit squares that lie strictly above D.
Yeah, I don't know.
So A equals A equals
Efficient.
1, 2. Oh, actually I'm getting this is like
A equals 2.
foul notation in
Strictly
matrices.
above. Oh, yeah.
Okay, so
It still doesn't have to be going to. You need to get kill the city.
That one.
yeah, I'm screwing up this notation.
What
Anyway,
do they call it?
for each non-negative integer. You know, it's actually pretty good to live stream. Like, if you're at home watching and you miss it, you can just rewind. Right? So you can use downtime to rewind. Yeah. So I guess if it push comes to shove, we can just like live stream weeknights. Yeah. Because otherwise, yeah. For each non-negative integer k, let fk be the number of peaceful configurations of n rooks on the chessboard such that A contains exactly k rooks. What?
Well, I mean,
So f of k is a function from what?
I mean,
What?
for n equals 2, f of 1, it's like only 1, f of 0 has to be 1 as well.
Oh, okay. So f basically is basically a mostly zero function.
I just missed one.
Yeah.
Huh?
It's like basically the zero function mostly.
Yeah. F of
Yeah.
1. F of
F of 1 is 1.
F of 1 is 1.
F of 0 is also.
F of 0 is 1.
Yeah, and f of anything greater is just really 0.
Yeah.
Okay, so you don't have that works.
Okay.
What do you think?
Yeah, this means freeze everything
We just can't.
equal. Oh, yeah, times.
Prove that f of r equals f of s for each pair of non-negative integers r and s.
Step.
What does that mean? F of r.
If
R plus S.
yeah, if they add fr plus s make the n minus 1.
Yeah. If r plus s equals n minus 1. Yeah. So this is 1 is n minus 1.
Sure.
Yeah. That adds up to 1.
Okay, efficient.
So if and only if, or
This is for each one. So if n equals 1, we only have like 1, 0, and 0. Yeah, that's just 1, 0.
so r plus s equals n minus 1.
So 2.
How many of the small cases have you done?
I've done up to like n equals 3, 4, like n equals what 2, n equals 2 and 3 don't really have anything special, like very interesting, and then you get to n equals 4 and then like, you get a lot more.
N equals 4, we have like
You have like
2.
you have like 1 and 2. So with 1 and 2 you have I think you have 11 each.
Oh.
Yeah, because with n equals 3 there's only like one configuration, and then n equals 3 has like 11. N equals 4 has 11.
4 has 11. What kind of peaceful configurations?
Yeah.
4 has 11.
Yeah, within like triangle.
Yeah, because n equals 3, you have like, you only have
4.
like 1, 2, 0. N equals 4, you have a bunch more different values for R and S.
Oh.
Oh.
Wait, so n equals 3. N equals 3 is not 6. So there's 6 peaceful configurations?
N equals 3.
N equals 6 peaceful.
N equals 3
yeah,
has, I think that's 6.
Should be like n factorial.
Yeah, n factorial, and then so there's only like maybe so there's one case for n equal for f of 0, one for f of 3, and there are
F of 2.
yeah f of 2.
You have to sum to 2. And then F of 1, because f of 1 is just same number. So there's only really one case, same equals 2.
Yeah, so it doesn't matter. So f of 1, and then like f of 0 and f of 2 doesn't really matter.
So the odd cases, well, when n is odd, you essentially just use a case.
So the question is to prove that if r plus s equals n minus 1, then f of r equals f of s. Yeah?
Yeah, so we're basically trying to find like a bijection.
Yeah.
Oh, are we? Okay. R plus s
Equals to n minus 1.
What was r and s again?
R and S are just like any the number of rooks above the diagonal.
Oh,
Yeah,
for
so-
peaceful configuration.
Just restart. Keep restarting until you see CL as a city. But that is the city. You can see the dude that spawns on this. But why? So you can say the test. But I think like if it sums to n minus 1, that's just the number of rows that's strictly below, and the number of rows that's strictly above.
Oh,
Yeah, so I thought you could do it with a 3D.
Yeah, but it's really hard because sometimes when you there's two configurations that you can get from one. If you flip, there's two ways you can flip it to get from one to get from like one configuration to two different configurations, and the other times you can't flip it to get any.
Oh, yeah. That sucks. This is not true.
Yeah.
It's just like completely surrounded by mountain. But like, what do you mean? What is it?
I can, yeah, if you get them wrong, I'm pretty sure there's one.
So like, yeah, that's fine. Just flip or something.
Yeah, and it's 4, and then I remember the configuration in 550. Or you can like flip it to get 2 of them.
Okay. So what?
Use pencil in this.
Oh yeah, I do select and flare up.
Can you get
Or you can have 0 above that.
Yeah, it probably is like when you mix up one to that. Oh, this is done. Nothing. Oh, that is absolutely trash. Wait, fishing. Yeah, you can get fish, but like they probably won't. There's completely inside.
if you see it blue. So
So for n equals 3, no?
I think it's 3, yeah. And then for 1, there's obviously it's
They're the same.
yeah. And then for 0 and 2, there are 1 way each.
So how do you get 0? Is this like you have to do diagonal? Or
For 0, yeah.
is this the only way to get a peaceful 0?
Yeah. And then for 2, it's like the opposite way. It's just one. You shifted one up. You can walk around there.
There's like mountains. Yeah, you can, but it's only one at a time.
That's okay.
Oh, so you don't keep it?
Awesome. We're doing making another something.
I'm just gonna not sauce it all quick around. After you like, so I'm just surviving. No, I'm not. Maybe. No, I don't
Don't
know.
risk it, I guess.
I don't want to. So
You sure? I think you do.
I don't. Because riders have defense 1. He didn't build anything.
That's in the rider.
Yeah, that's a warrior. Warriors have defense 2.
Okay.
What an absolute.
Wait, that's the 12.
Yeah, what? The 12.
Yeah. I'm pretty sure we watch our warriors as well. Pretty nice.
Oh.
Sometimes. Well, now we get stuff. Hey.
Like nothing right now.
But yeah, we can research first and then.
That's it. Okay.
Did you already do any before?
Sort of.
Okay, back to this.
So when R there's 0, 3, 2, 1.
2 plus 1, 0 plus 3,
yeah.
3, 2,
1. 0 is the same thing, and 3 is the 0 and 3 it's the same thing, and then with 1 it gets interesting. Your board's not gonna have enough to fill all
What? What'd you say?
the whole board. Like if you try to put them all on the same board, it wouldn't work.
Oh, you mean the cases?
Yeah. Because now there's a total of 24 peaceful configurations. So that means it's not
Oh, of course, this is if it's symmetrical because of the axis. Because to all the same flip it.
Yeah.
And then if it's not, you can flip it on both axes.
Yeah.
So one by that flipping those.
But those might repeat. Might have repeats if you flip it. If you flip it like, if you flip across diagonals or like,
Yeah, of course.
oh yeah,
because when you flip it, doesn't change.
yeah, but sometimes like you might like you find two configurations, right? At the other time you might find two configurations, but one of them is a repeat of the previous ones. Because with every configuration, that can also be.
Okay, I think it's like.
Oh no, you can't actually flipping it this way doesn't do anything. Because
because
everything is stays in that station.
okay, I think I'll just try to draw all of the ones with four.
There's
So you can find some.
Yeah.
There's a lot, but
I should have bought like shooting yesterday.
Okay. All the peaceful configs with four. Do you go hunting or do you go? Hunting is usually better. What's the options?
Well, we have everything. Fruit.
Yeah, hunting is normally good because you get forestry after, and that boosts it. Okay, so how many were there? Oh, that should be like 24. Right?
Yep. Well, 22 in total if you don't bother with the other ones. If you don't bother with the one,
What?
if you don't bother with the 0 and 3 case.
Oh, no. Cool.
I feel like we'd get invaded.
Genius is big.
I used more when I did this.
Oh, you can draw 50 ones.
Oh, I didn't know.
I'm just line them up and draw like
I found shoes on that. I didn't realize there was so many.
I
don't know. I realized I counted in my hand and there was 9. I'll start filling them in for you.
Yeah. There's 2. X.
I don't actually know the other one. That's the one case.
Okay. So, I love the panics.
Yeah, I'm gonna move this way.
Yeah, just in case.
You can jump.
Yeah.
Oh wait, what are you drawing with me? Are you drawing gap between the?
Yeah, that's the one case.
Yeah, that's now we do 2 cases.
8.5 foot. That's not a square. But whatever. What? Valley Group, Valley City Group. Scores. Yeah. It's spotted. What? Perfect.
Alright.
Okay.
I'll just do them while you figure out what to do here
Okay.
because I drawn half the diagram.
This is teamwork.
This is teamwork.
One of you make sure the game is being attended.
Yes.
Well, because if we have two of us doing this, it repeats, and that's bad.
That's the rationale.
Yeah.
The reasons for the maths are simple. The games are complicated.
True challenge.
The zero is always the diagonal.
Hmm.
And the
Yeah, it should always be the
above diagonal.
because if we have like one below the diagonal, that means it's got to be like above.
I'll do that.
And what? This is why you call this in pen and use pencil. Have tips and tricks.
Are you saying there's tons of combinations with 2 plus 1?
Well,
Apparently there's 22. Yeah.
let me do.
So, yeah.
Oh, you draw. Okay. Wait, you do it.
Yeah, because they have like an event of like 1, but an attack of 3.
Oh wait,
So-
why? What?
Unicorn.
Wait, is that just the thing?
It's one of the special tribes. You can do it.
Oh.
Which one did I miss?
22. Huh?
No, I should draw 11, 11, and then 2.
Yeah.
So we can find the projection a bit easy.
I'm just looking for because I missed one of them. And that's bad.
Well,
Oh, wait, no. Okay, so we have this, and then I didn't figure out what I want. Oh, yeah, okay.
okay. And then this will just. Okay. That's interesting.
Okay, so by injection type.
They translate the entire thing down to spaces.
Oh yeah. Yeah, because there's like you can either translate or reflect. So
Seems interesting. Yeah, translating down.
and then you realize these are from the same group, and you're like, these are from the same. These are both ones, but they look the same.
You're saying there's 22 ones.
Or
Oh, 11 ones,
11 ones,
11
11
twos.
for
Like F1 is 11.
F1 is 11, F2 is 11.
Oh, okay, yeah, that's more related.
Do we get anything? To make
I
another
don't know if
source?
I'm going to
Make another source. Oh, we'll make a writer for that.
We don't have right.
After
We don't
that.
have right.
That we want that, right?
Yeah. We can make a warrior. That means I can get
Tree
forestry next time.
Okay. And then we can go lumber huts.
Not the hot on very well.
Really? Wait, one population.
Yeah, but
Wait.
we could just like
Kill that or step on this thing. Step right.
oh frick.
Wait, you should
That is not free real estate.
Wait. How many kills is he on? How many kills? He's on 2 kills, right? Oh no, he's on 1. No, it's
Damn it. Oh,
okay, let's be honest. It's better because we did some exploring. Now we can just kill. We have to kill that guy. Yeah,
it's bad.
he might not kill you. If he doesn't kill you,
He might. Okay. I can like chop.
move this guy here. Chop. Wait, can you chop? Is that a?
Yeah. I can get 8.
Yeah.
And then
Oh, you can get
8. And
yeah.
then
8. But one population gives you more growth, right?
Hmm?
There's no other way to get any population.
yeah.
Sure. Go ahead. Should we try to do some projecting?
Maybe not translation.
Yeah, because translation is too complex. You get 4 combinations with one translation. With like you just translate it, you just repeat it 4 times, right? You get 4 different things.
Oh, I just meant like 2 down.
2 down.
But yeah, that falls to this trap.
Yeah,
it sucks. So I have to consider the diagonal.
Let's find ones that look like they project.
Yeah.
That one. That one.
Just sort of mark them or something.
Yeah.
What do we mark them?
1. And then write a circle, draw a circle around.
Yeah. And then what this do? This. Oh,
okay. Well, we got one. It's okay. We can use this
fine.
instead.
So this
We can project that with that.
9.
No, it looks like you got something.
This is 9.
9.
No, we're like
We're just finding stuff that
Just-
seems like a project.
that
That
look
look kind
like-
of similar.
like matches. Yeah.
Because right now we have this one, and this one look kind of similar.
It's like match up the
They,
pairs.
they seem like
Oh,
matching,
like that.
and then this one matches that one. So right now we're like doing a flip.
Yeah, and then we can sort of
We can
hopefully find that.
Yeah.
Oh.
Yeah, so
Like
we draw them
like
all
a
out. and we
rotation
try-
or something.
Yeah, like well, it's reflection.
Might be rotation, reflection.
We just have-
No.
But what? We can't do anything else.
We have to forestry stuff.
Wait, really?
Bob.
But no, we gotta bop this one first, right?
Hmm?
We bop this.
We bob all.
No. We keep these so we can fish and then get this and then make this go boom.
I suppose. Yeah.
And then we wait.
Fish is 6.
Fish is 6. No, but the thing is, right? If
We need more trees.
we have 3 trees here.
And then it makes 6 and we get frick.
Oh no, we have fish here.
Yeah.
So we cleared 2 of these. Lumber hut 1 of them. Oh no, we clear 1. Lumber hut 3. Lumber hut 2. Fish for the 3rd one, and then that operates, and this one operates too. So we just clear 1. Clear 1, get fishing next turn.
We're going to get fishing next time. I suppose.
And just clear dodging.
Looks bad.
Okay.
Skulls.
Yeah, no.
Oh, so you're like rotating at 90 degrees.
It should be something like that because it's like a diagonal. So if like somehow swap what's on the sides of the diagonal.
Okay, well,
Why don't they give us anything?
well, we got saved.
Oh, nice.
Now
Let's
we get
kill
this
it.
guy and give that ring.
Off. Why are there so many just chilling in the corner?
Don't know what he's doing. Alright, now we go fish.
I suppose we'll just move this.
And then next turn we just go
with this boy here.
oh so I go for that. We just,
Explore. Oh, yeah,
defend.
I don't know about what this guy's
we
doing.
one shot him, don't we?
Yeah.
Bruh.
Damn.
Alright.
That was just a buggy.
No, dude, he's not.
Yeah, look at this.
Do we just bop that guy?
Huh?
Do we just bop that guy?
Oh, I suppose you can.
Oh yeah, because we have.
Oh, yeah, I see.
Alright, we come here. We just put this. Oh, we can do this one. Oh, yeah. This is
At the moment, it looks like
if we flip over.
yeah.
But then we can't flip anymore, I think. But
That's
yeah.
sort of fall.
A lot of them we can't flip.
That's sort of fall.
Oh yeah, and this is you have to do this in the correct order. You have to do these first to get resources to do these. Because right now you have 6. Yeah.
Sucks. Yeah, that doesn't work. That goes to here.
Very nice. And what could go wrong?
Nothing. Oh, here's 20 health. MP. Perfect. So, thank you. Oh, okay, it's actually not bad.
It's not that bad. It's alright. Hey, we're winning because it's not easy. Oh, that's pretty good.
That was good as well. So don't
Yeah,
like resources.
yeah. Oh, like something.
Well, you made a friendly giant.
Yeah. Oh, yeah.
Oh.
Wait, what do I do with this man? Recover.
Oh,
Or do I just
maybe-
kill this
Yeah.
man? Okay.
Oh,
See, that's good.
Yes. Or skill.
What should we research? Should we get sailing or riding? Once we get that, that's a lot of fish that we can put here. But riding, we can explore. Riding, we can explore this side.
Riding would help us kill Imperius as well.
Oh,
The blue dude. But
we'll go riding. And should we just make a rider?
can you? Oh, sure, yeah, go ahead.
Yeah, how are we gonna budget this one?
So like
Yeah.
oh,
Oh, well, we can get sailing right now
because
too.
we can't flip this. Right?
Yeah, we can't like. Is there any we
it
can't?
has to, like,
There's some.
translation of some sort.
Yeah.
Also, no.
We can get sailing and then capture that. Sailing first and then capture that.
Yeah, roads helps.
Oh yeah, true. You're right.
Because we like clutch roads.
Yeah.
Oh,
What do we do about these guys? Do I move him? Oh, we have a warrior here. We should move him. What do I do with him?
You can kill that Imperious warrior. That one there. Probably move him back one.
Yep. Oh no, he's dying. We can make a swordsman now.
Yeah.
Jesus.
Oh.
That's a turtle.
Hmm?
We kill turtles.
Oof.
I'll make a swordsman.
Yeah.
I'm make this guy run back.
Hmm?
What do I do? Do I just sack him? Or...
It's coming. Maybe.
I think I let move.
Or we could even recover.
Hmm?
We could even recover. Because he'd have to use both his attacks.
Oh yeah, sure. And next turn. We'll build a port there next. Well, what are you trying now?
Translate.
Oh, okay.
One to the left. Wait, no. One to the frick.
Why he didn't attack?
Just translate one.
That doesn't kill him. Okay.
Damage is weird.
Yeah.
I think it's based on remaining health as well.
Oh, camp.
Oh,
That's a pretty good camp too.
first uncaptured village. 1, 2, 3, 4, 5, 6.
Report. Wait, well,
Oh.
Wait, are you redrawing it?
Huh?
Where are you redrawing them?
Oh, I don't have to do all of them actually. Let's try a few for now.
Yeah.
Yes. Let's go to oh.
I think I'm going to select.
Oh, you do one, yeah. So bijection doesn't have to be like one transformation, does it? It can be like if this, then do this translation. Otherwise, do this one.
Yeah.
Or this one.
Or the other one.
Yeah. Oh, it's complex. That's what I'll start here.
Climbing seems good now because there's too much mountains. Have you sorted out what happens on the diagonal? So like the R plus S is kind of meant to be equal to N, right? N minus one, yeah. Sort of. I guess that's the idea. Why is it N minus one? Oh, because
The diagonal, you just don't count. If you translate down one and you reflect, it seems to.
So if you have one thing on the diagonal, right?
Yep.
Then it's just the reflection. And it will be reflecting. Yep. Because they have add up. Yeah, they add up to N minus one. Yeah. Wait, translate downwards one.
Oh, you don't.
Hang on, aren't these the same?
Yeah, well, that's reflecting across the diagonal.
Okay.
It's not necessarily that, but it might be.
Wait, so you move them down one and then
Move everything down one and reflect. Okay. That seems to have worked for these four we've tried.
Yep.
7 more.
Oh, well, if you have two things on the diagonal.
two things on the
If you have two things on the diagonal.
Yep.
Like 1 and 1, right?
Yeah.
And they add up to. Then the other stuff adds up to
N minus 2.
right?
Yep.
Which is like the n minus 1 of the previous case.
Oh.
So like if you don't have, because
Yeah,
you don't
yeah,
have
yeah.
that, then that's just
And that's interesting.
Yeah.
So you could sort of induct.
Yeah, I guess. A little bit.
That just works for no matter where the two are on the diagram. You can just take out the crossword.
Yeah.
Okay. Oh, frick. My pen is dying. Luckily.
Oh,
like if you consider a minor, yeah,
Like,
like if you remove, you know what a minor is?
mm,
It's like if you have like a thing,
uh-huh.
like the minor for that is just you take the matrix. Well, I don't actually know what the name is anyway, but like you take the row and column and remove it,
Okay.
and then look at this the smaller matrix.
All right. Yeah.
So if you had 2 on the diagonal, you could remove one of them.
oh, you just
Yeah, you just
yeah,
pick one of them to remove. Yeah.
And remove one of them, right?
Yeah. And you want to put another one. Yep.
Always feels good to use. This is a bit like
It's basically, yeah. It's for, okay, the standards have lowered over time. But generally, like dry, non-biodegradable stuff.
but non-biodegradable.
Just stuff you can leave there indefinitely.
Yeah.
Because it's not getting emptied anytime soon, that's what I'm saying.
Yeah. Okay. So empty pen cartridges work.
Yeah.
Stonks. Refill.
Oh,
But
wow.
it saves something.
Oh, that's cool.
Well, yeah. No, that has ink.
Ooh.
Okay. Wait, let's try for the next 4.
Does that work? That just works, doesn't it?
Mm-hmm.
But maybe a bit complicated to write.
Oh, you're like the inductee bit.
It just seems to work.
Oh, by the way, did you guys have a chance to look at the Kosovo? I know you did.
The what?
Kosovo, the picture on the WeChat. Kosovo TST 2020.
Wait, the one you sent
Yeah,
first?
yeah.
Oh,
Oh
no.
no, so there was Kosovo, India, and then today's.
You sent 3?
Yeah, I sent Kosovo on like Thursday. I sent it as soon as basically I heard you said you were gonna do surfing test.
Well, I didn't have a look at any of those.
Maybe we could save it for tomorrow
Are these all?
or lots.
Are these all different? I think these are all different.
Oh, really? Wait.
Oh, sick. No, yeah, I think this.
Wait, is that all 11? Oh, yeah.
Yeah, this is all. And then these should go into 2. Oh yeah.
Oh,
Yeah. The random guest.
wait, hang on. Oh, wait.
Found the budget.
He sort of found, yeah, he found something.
Huh?
He found something.
Yeah, I found the bidirection.
Oh,
Well, for case 4, but like,
Yeah.
I think that should generalize.
It probably generalizes,
It
yeah.
probably does.
oh, what is it?
He shifts them all down one.
Shift them all down one
And then flip
reflect
it.
across the diagonal.
Oh, that's a good idea.
Cool.
You shift them back up.
Yeah, if it's at the bottom row, it just becomes the top row when you shift it down. So you shift every rook down one column,
Yeah.
and then you reflect it across the main diagonal.
Do you do anything else after that?
That works for. Yeah, that works for these ones as well. The 3 and 0 case.
If you shifted it back up, I would say conjugation.
Like the under.
Yeah.
You should do that. Well, shift down when you reflect.
So the shift
To do
is
the opposite, you reflect and shift up. Yeah.
I feel like shift is clever because of the diagonal column.
Yeah.
Wait, so what happens when you shift it up above the top? It goes to the bottom.
goes to the bottom.
Oh.
Yeah, that seems to work. You can take it off as well.
So like you plus one more in.
Yeah.
Yeah.
Oh, okay, so what you do here, top the rider. Frick, you can move 1. Why can't you move 1?
Sitting wall.
This is true. Okay. This is where the roads go.
What? You can build a road there?
You build a road anywhere that's not enemy territory.
But he has a.
What? Oh.
What?
Sorry.
It's at the edge of the
Mechanic. It's because
he
you can't move one space if there's like an enemy. Yeah. Oh, you have climbing.
Yeah.
Oh, that's fine. Never mind. That's my bad. Wait, why'd you recall?
Oops.
Oh,
Okay. Oh no.
you could have killed him and then used the bounce from the rider to get into the city.
Yeah, we're gonna do.
Oh, that's fine.
That's
You're probably you're destroying right now.
Wait, I kill this. Get that.
We'll see if I can generalize. Oh, no, well, it shouldn't be too bad.
Yeah.
Send is like a bijection. And then, moving up and reflecting should undo it because like over here. Yeah, or reflecting then moving up is the conjugate.
Yeah.
And then we can
Oh, we need a way to kill this guy. We need to kill this guy.
kill him.
I'll just watch him there.
Oh, okay. Aha, here we go. And then we just have to prove that they're all unique. Essentially.
Yeah.
Which
Well, yeah, it should be
that
because
should be-
it's a 1-to-1, so it has to be unique.
yeah.
Unique fight easy, proving it's all.
Unique part's easy, and then
So
undoing.
you just have to show that like it takes R to S.
Yep.
usually does that. Because you shift down one and reflect. And as well, you only get the same thing if you start with the same configuration. And then reflecting and shifting off is the conjugate.
Yep.
So done.
Well, I think she's probably been stuck on that island.
So what do you do? Shift up and reflect?
Oh no, shift down and it might not make a difference whether you shift up or down. But what I did was I shifted down and I reflected across diagonal.
Across the thing.
Yeah, across the
Shifted down? Did you say down or up?
down.
Down.
What do I move to that?
What?
Do I move that right next to him, or does it just die?
Has your knight attacked? No.
Just move. Well, I'm pretty sure you can launch all of these.
Alright.
Nice. Okay. Alright, he stays there. We kill this next turn.
Yeah.
We build another.
Oh, he has a hidden C. Okay.
Meanwhile, this guy just
Probably explored them all.
yeah,
Yeah, that's in the task. I don't know who that is. It's Zavasi. Probably.
So if you shift down, then reflect, right?
Down and reflect.
yeah.
And that means the stuff that starts on top
Yeah.
all ends up down the bottom, right? Like the stuff that goes down,
The stuff
Like,
at the bottom or
the
at the bottom.
furthest, like the furthest it can shift down is to the diagonal, right? In one go.
Yep.
And then it gets fixed by the reflection.
Yeah.
So it's again out of the top.
Yeah. Okay. So
So everything that starts at the top leaves.
yeah,
Everything that starts at the top
leaves.
leaves. Yeah.
Yeah, and
I think
everything
everything
that
else should go back. Wait.
no,
No,
not necessarily.
If
So
it goes
if it's no,
So if
because
it starts on the diagonal,
where is an example? If it's here, then it goes down and comes across.
no, it goes down and flips, right? So it goes down
Which way are you flipping?
and goes that way.
Oh, it's flipping
Flips
across.
across the main one.
Okay.
But yeah. But everything above, go down and flip goes to below.
Yeah, everything above goes down and flips onto the diagonal, or like
or gets flipped down.
Gets
And if
flipped
it was on the diagonal, it goes up to top.
yeah.
If it wasn't on the diagonal, it wasn't above the diagonal.
Then that's just in the corner there. Because if
It
it's
could be all of these, right? Like
What?
this, his voice.
but they get flipped up to the top, right?
After these ones you move down.
Well, okay.
They get flipped over.
It's interesting. What am I missing? So if this goes down, it goes to the top, but then it like doesn't.
Wait, what? If it goes down, you're actually flipping over diagonal.
Yeah.
Yeah, so it goes there. So, but if it's here, it
No.
goes-
Say if I had one here, perhaps, and it goes down to the top, and I flip it.
Oh, right.
It leaves, though, and that shouldn't.
So wait, did you miss something here then? Because if you flip, you moved everything down, right?
Oh,
Oh,
this
did you
is-
flip
this
the
is
other way? You
different.
flipped the other way.
No, this is a different one.
Okay.
Yeah.
All right.
What happens here?
That's
This one.
Right, they're in order.
oh,
So this one goes down up here, and it flips. Oh, because there should be a corresponding confusion.
wait. I want to think. Hang on.
Oh,
Oh, because there's n rooks. There should be one which just like doesn't really do a thing, and that's the one at the bottom.
So what do you mean?
That's the one in the bottom column.
Wait, what do you mean? Doesn't really do a thing?
Well, because so you have
All right. Yeah.
It's to start
Yeah.
with
They need that
-1.
to n-1, right?
yeah, it has to go to n-1. So that means that not all of the ones that are above the diagonal have to go to
Not all the ones underneath
not
diagonal.
the
have to
ones
go.
all the ones underneath have to go to the top. There's gonna be one which like doesn't.
And that has
At
to
the
be the
top.
bottom row.
That's gotta be the bottom row.
That's always the bottom row.
It's always the yeah. And
Anything on the
only
bottom.
one.
It's any on the bottom row.
Yeah, there's only one in the bottom because it's
Yeah.
peaceful.
So one of the bottom row one doesn't go anywhere. It doesn't go
well,
back
it
to
stays in its section.
stays in that section, and then everything else gets flipped
Everything else
over,
flips over.
or it gets flipped out.
Sick. Right.
So
Okay.
basically every like in the thing in the bottom row after it gets shifted and flipped, it's still in the other side.
Oh, yeah. So if it's in the bottom row anywhere, when you shift it, it's gonna go into like this
Yeah,
area.
so
up
let's
here.
look at the one that example. Yeah,
Yeah.
that one goes to the top.
Yeah, it goes to the top
And then
flips
gets
across. It stays
Yeah.
in this sort of section. Everything else, though, when you move down and flip it, it should go into the other section.
Yeah.
Yeah.
So
So
it's basically the top right 3x3 sub thing.
Yeah.
yeah. So that area swaps.
Oh
And
yeah,
then, like, the
because
bottom row doesn't.
it's just everything in here,
Yeah.
and there's like 6 in there,
Yeah.
and there's the other amount in there.
essentially.
Yeah.
So you basically ignore this bit.
Yeah.
And then you flip them.
Yeah.
And it flips.
Okay,
It's sort of. Yeah.
That's interesting.
So I'll explain sort of why
Yeah.
it's n minus 1. Because
Yeah.
you just ignore, bro. Okay.
Oh,
Oh, nice.
So random guess. So,
It worked.
Yeah.
It worked really well. As well.
yeah. Okay. Is Edwin still listening or
I don't know.
maybe?
Press like if you're listening.
Oh.
You know, it is. Oh no. Right here. Okay, we hit these. What's that?
That's what can we do? Okay, so you want to like slap that?
Do slap this one.
Yeah.
Let's slap this one. Become bad.
And I don't
Why
know if
can't I
you
hit?
Oh, you might. No, you don't. Yeah, just slap him and then you can catch. Okay.
Oh, maybe I should slap the other way around, right? 'Cause-
Well, that's
Oh, it
fine.
doesn't matter. It's not at this point. Though.
Yeah, it's not. Yeah.
Come here. Come here. Make this go down. Come here. Okay, that's going down. Get this. What? I mean, it's alright.
We want text.
Oh, and there was not that bad.
He's just been like chilling.
Yeah.
Oh.
Alright. We just move another soldier.
Yeah.
I know,
Probably,
like knight.
build an entire fleet.
Yep. And then we put another guy here.
Yeah, you can offload a knight and then you can just kill everything else.
Yep. And then we now take this one.
What
Oh no, we get to fish. We get to whale.
stonks?
And then build roads.
Should we just leave?
Yeah.
Yeah, that's
Yeah.
okay.
Road. Wait, what did burning forest is useless. Right?
Yeah, burning forest. Yeah. Okay.
guess what we're trying to say, like, all people in your life, they turn into good, expecting more about a loved one, time before they time. That sounds so scary. You guys in the morning, one of the viewers said his mom was how many good is oh, yeah, and then you could just like one role. Maybe just maybe fine. But like that's considered like for some reason that's evil, right? Whereas that's like more possible. Yeah. And also they're gonna regret not right. Well, I mean that's probably what the discount yes, but that's the base price. Well, it's not like people, but people are gonna go to the people for the thing possibly. Now all the people producing clothes they would have to just do it all day. Yeah, the one like produce as much whatever you can, whatever you produce will be sold. Okay? Yeah. And after that, you'll never sell more. Just make clothes make up your life, like the life of everyone. Everyone.
What was 4 to 5? One was a topic to me and there's no business to rely on myself this year. We started we united the Venezuelan power. I was for it's like oh yes oh but like it was not groups into it. Oh, it's the Taliban one like the rational ads for like what happened the like actually for that's the way so like that you can solve all the things solve the the point is you solve all the very yes, you extend it in a way that reflects that. And then if you get a corresponding group, anyways, like the groups have to have this property and like it's kind of obvious if you find it that way as some property. And then you see that like none of them have that. They go down.
Oh, okay, so it's normal. But I wonder how many people have already had it. Sort of funny, like, I was studying this guy was like, I used to be really good at basketball. Everyone was talking like, oh yeah, I'm back there, all back there. But physically breathing because of my back. Everyone's left. Oh yeah, so the reason we have prayer on Friday is we look at that music and put it in voice. So we decided on it's like getting to the point where the empty menu is a bread. We want to minimize any and all thought. This is no longer unfortunately we still live in happy. Like, because the Bible really goes there. Okay? So that's about a year. And apparently, like, it's like, apparently, making jokes about coronavirus, like, touching everything. Like, and then, like, just before the next game starts, he gets tested positive. So all the videos of like like went viral, and then NBA goes. It's really funny because like it's also really like you gotta remember these guys in the NBA. They're like they're like not even late. It's like borderline week one. So they look like they're freaking. They're full grown men. They look like they've been grown men for ages. Yeah. But they're just little kids basically. So they're just doing that kind of stuff. So you can't really kind of live it that way. Oh, yeah, yeah. Nice. Yeah, Lisa was Lisa is shit. It's like yeah, and it's just like it's a hand in her mouth.
He makes a happy, he makes a liver to
Yeah. I look up the leaking the fingers in the face.
Yeah, I know.
It's such a like a weird thing.
Yeah, I don't know why.
I've never had a page that needs to be turned.
I never had like the language would be easy.
Yeah.
I've never tried, but I wouldn't ever try.
Yeah. Like you must really like the finger. That's pretty much the end of the day. You know that I feel like the taste of nothing without it's really obvious. It's like that scene everybody can do reading. It's like a little bit of sugar on his face and the other way to go.
Yeah. have it in a pop-up. It's one. I feel like it's the same. They have the same ingredients. The other one might be like 30. Maybe that's how like the percentage is how many stuff. Yeah. It's pretty fun. Like it's like after all this time, it's just like what we realize is all the crap people do are understand. That's all we do. The life just gets cancelled. Okay. And that's it. Like, the only point of boarding school so people wouldn't have this kind of irrational feelings. Could be educated and aware of facts and information. But since they come out of it in their life, you get this kind of school. Formula One got cancelled. Oh, and then the NPL said they're going to hold their grand final to go to George. We didn't get anywhere. Yeah, it's like, this is not like have that as an excuse for you having no ability. No one's coming to those games, right? The UK Prime Minister seems like he's trying to do something different. It's like we can't all like isolate right now because I reckon if you do, you'll just get tired of it by the time the actual peak comes. Yeah. And then you'll be screwed. So we're gonna wait until the situation develops and we're slowly transition back. And I'm like, oh, right. And then it just gets completely bombarded with crap. Ireland's doing it, everyone's doing it, why do we do it? It's stupid for everyone else. Are you just not there about us? You're aware that always like that's the problem. Like you act, like, the way that act. Try to do like the best decision. I think it's hard to find good source of nutrition. Not that I like it that much. But really explore the he did this one of the news that people are in hospital, they don't want to be treated by Asian doctors. Because they're like, well, then, well, actually, they're like, I don't want my kids treated by Asian
That's not racism. People just think that's racist. That's not really racist. That's just stupidity. Like it's another form of stupidity. It's like they have reason. It's just not. Yeah, like it's horrible. It's like, yeah, it's like they have an excuse. Yeah, it's like if someone's bright hair color with the light somewhere, you're like that's my. Yeah, like that's not. It's not really racist. It doesn't make any sense. I think it makes sense to them. That's the thing. You can understand how they can understand that. Yeah, and the death rate thing, it's not just that everyone gets it as a random 5% has died. It's not like that. Yeah, it explains stuff. Yeah. And then like you said, people will die before their time. It's like, you're 64, get it now. Don't turn 65 and get it. Get it right now. You don't need to get it. Save who you are. Get it as soon as possible. So as far as I understand it, like the strategies like this, it's like there's no cure for it. But you can kind of be helped along by like ICU or something. That's something to help you breathe. Yeah. So like you need like the number of people that need to be helped breathe is smaller than like the number of ICU. Yeah. So actually, when at the start, when like the ICU is empty, that's not good. You need like constant. Yeah. Like, you don't want them to be too few cases, right? Because there's so many. Yeah, like you want like at the start, we should like make there enough cases so that and then it'll all go. So I don't know if the ICU help. Like there's no way they can actually help you. I don't know you can apply. Like I would hate to do the one. I'm sure it's everyone's dangerous person at any time. So if you go to hospital, they just go to them. Yeah, it's every time. Yeah, exactly. Like yeah, yeah, exactly. Yeah, that's kind of what happened with Michael. Is like he had like this weird panic attack, and then like it's hard to do anything because it's before. But I just don't want to do anything. Then we put ambulance, and then the ambulance just came and looked at it. I was just like, oh, I don't get it. Wow. Give me my $500 back. Yeah, I didn't know if you could have that. You ever seen that? Oh, that was she had a seizure. I didn't even know that. I didn't even know what that was. So he's like the first time he came out, second time he came out, brilliant. Third time he came out, they weren't like doing proper procedure with it, because they were too worried about coronavirus. It's like, where would it be traveling to China for 14 days? Have you traveled to China in the last month? Yeah, I guess you could say in the last month. Oh, okay. Alright, well, these were face masks when you're visiting us. I'm like, alright. So we go there, right? It's easy to face mask. Alright, well, and then my mom was worried about, like, oh, is it was easy now? Should we tell them that we guys just tell them, right? Like, he has a fever. Yeah. Sure, this is I was like, alright. And then they were like, asking the same kind of yeah. But you know what to do. Like, it was kind of like it was good because it was not, it was like, it was borderline, not serious. It wasn't serious enough for a hospital, but it was too serious. Yeah, I think I can't do something. But they were too worried about this, basically downplaying the problem. Like, just waiting, and then as soon as the doctors like see him, they're like, oh, you're good. So, like, so the voting is pretty bad. I mean, that's how it's like, yeah. Like, the final death, three steps, and then there's no other parts to death. Yeah. So like, but I think, yeah, so it was weird. I was with the doctor, right? And then the hospital, the doctor was like, asking, and then called someone to find a period of time. Like, oh yeah, okay, okay. What is the plan of procedure? Then we go through the doctor. Like, so there's like take an X-ray, check for pneumonia. Okay, the strange of pneumonia is so soon. Okay. So it takes it. And then he says to me, and he says, it looks like it could be pneumonia. And the X-ray, but the X-ray doesn't confirm it's pneumonia, and it doesn't say it's nothing. There's something there. We don't know if it's pneumonia. I don't know. And then she's like, okay, I'm gonna treat it for pneumonia. Okay. So antibiotics. It's two types of vitamin bacteria. So it's like, so I'm like, okay, so and he's like, so she's like, I'll take these things, and it's like, he has more trouble after this, come back to one. Oh, so you mean like it's all bacteria? Yeah. Then we have to come back. But yes. Okay, and then moving on. So it seems like he's getting better. Like, you can't tell if he's getting better on his own. So, and then I go to the doctor after the doctor opens up the hospital, and it says he has pneumonia. Like, it's like totally different from what she said to me. That we're not sure what it is, but we know it's not nothing. That's exactly what she said to me. And then on the letter, it's like he has pneumonia, and then we're treating with antibiotics. Apparently, 2/3 of the money is antibiotics. 1/3 is yeah. I think you can recover from it on your own. Like, a large part of the problem is like, it's kind of like fever, right? It's a fever is your own body feeling like itself. But sometimes your own body is tired and makes it too hard. So, like, that's what happens with the lungs, right? Like, it inflames. It inflames too much. And you can't breathe. No. But yeah, like it's weird because I started realizing that like the way these medicines and shit, like so, like they have like the disease is classified separately to the sort of like the cause of the disease. You know what I mean? Like all lung problems are like pneumonia. It doesn't matter how you right? Or like yeah, like it comes down to like a small environment. Like I used to think pneumonia was a thing, you know, like oh you had pneumonia.
Yeah.
Why are you specifically coronavirus? The hand sanitizer doesn't really help that much. I mean, the antibacterial part doesn't. It's the alcohol that helps. Just have a big. It's made by Australia. Yours is so well. That guy make it. Is he Australian? Not sure.
We were just actually do some so we cut that out and then this was playing in the background. And we just listening to it. And I think just saw we had it. So it was like we got a moment. And we just listening to it, okay, we said that and like see us do that.
It's funny, like you can have like a formula for that. Like if you kind of just like decided to do it, you could just like turn that into like a joke factory.
Yeah.
Dude, like, it's like I just thought like the straight like that's like a stereotype, right? You can't imagine it. If you actually play basketball, like the people are like that. Like, yeah, when I went and trained for basketball, right? Like the coach was like that. Like the basketball was basically the coach, and the bigs were like the people of the team. Like it was like it was totally just like that. So oh guys, you're gonna play North this weekend. Going down.
added 9 times instead of like 24.
So this is making pizza.
Nice. Well, the original thing, yes. I know.
That's what was pretty funny now.
Okay.
You know how people look at crowd references and people look laugh? It's like I find some people are laughing like because they take drugs. Or like most people are laughing because they take drugs rather than what the hell. Okay, so apparently you know like Australian like fight against drugs. You know what they do? So they have like a police department that permanently reside in Mexico. They kind of stop the people that even leave Mexico. Which actually is not a bad idea, right? Because like I mean, if that's your goal, okay? Like, if your goal is just to get more of a priority goal, but like, if your goal is to smoke drugs, because in Mexico, yeah, I think you can just kill anyone you want, right?
Yeah.
And like here, you have to like probably like get a warrant, right? Yeah, mind you, they can kill you too. That becomes the thing, right? Yeah. But like, I feel like it's really hard for them to make profit. Like these people, they go there and they learn all their marijuana crops and everything. It's like, how can they grow it? And then when they see the crops, they're like, oh, this is a street value of $100 million. That's BS, right? Like, as if you can like, yeah, like, you have to actually sell that to get $100 million. There's marketing issues involved.
So, minus the what you need is study that.
What?
You just study that. So then, so it's not like the guys or some guy who did development was you going to be like you know somebody and you're doing the same thing. And that was like this. There's one thing was minus and then he goes to become he goes to that. And he's still going to see one minus was. And then like he asked about it and then I go I see him, you can see that it's like the whole stuff. And then I go whatever we do. And then another one day I do that. Some dude like I just saw minus movie out of the standing up. That's good. And then they went, what the hell, why is he doing that? So like when I exited that, a single handling that stuff will be like he just made it like he just made the statistics like he made the average recommendation.
Yeah, it's honestly a huge deal.
And then like no one else knows the course, and he just like and he just like went and then just like messed with the stats because he just makes that and no one else knows it. So then he like finally like single-handedly screwed up the average and everything. So then the pass mark was like 75% and yeah, what it is like the average cost standard deviation, cost standard deviation, and then so he might have no way otherwise than most people would pass, but then he just made the he lifted up the average and made his standard deviation. So then, yeah,
Oh, you don't know what it is standard basketball. I did a standard third year basketball for my first year, and the students there were like, how many teachers? They wanted to. Oh, wow. That's the one. Yeah. Yeah. I mean, when I first started to do back from I was looking at those forums, and some people have a really like it's not like I like I'm not like someone who reads that all the time, you know. It's like I'm just it's like I have lots of things going on in my life, you know. Like all I'm doing is studying to be a full-time math teacher. Yeah. It's like I have other things going on, you know, so I didn't need to like go my stuff. Yeah, I need to know to the point where I can pass, you know. That's what he's basically saying, yeah.
I think everyone else.
I didn't need to do that extra stuff. Like that would mean I cared about it that much.
Yeah.
I only care about it so I can earn an income to support my hobbies, which is what I care about. I was yeah. Well, in Australia, you could basically do that. It's like everyone gets paid the same. You go into anything just for the money, and then kind of at the end, maybe you realize your life is like, oh, sure, you support yourself all the time. I really wish I had money to buy shares. They seem to just stock markets.
Yeah.
Lost 10% in one day. Like, I hate it, and then they always say the same shit every time. It's like, the only certainty is uncertainty. Like, I think it's quite like that. But like, it looks so obvious what's happening. It's like panic selling, like, and then the people who are like smart and have money, they're like, "Ooh, let's buy something." Panic selling. Or basically, or in other words, like panic selling, profit buys. Panic selling, profit buys, and everyone else buys. Yeah. It just seems like it's the only one that has any money. Like what he does, it seems so sensible, but like I don't think anyone does it. Yeah. Maybe we'll see some certification. Because it says the same thing every time. And it's just the most basic of shares of kind of thing. Just like basically it's really like business. Okay. So the value of business doesn't really fluctuate like the price of the shares does. It's really like how much will this business make for me that determines the value. If that happens to be higher than the price of the shares, I buy the shares. I'll have to be lower, I sell the shares. You know, like very simple, right? And then every time he says it, like, like, oh, what can you say about markets right now? Why this isn't nothing you're feeling and all this stuff? Like, oh, you know, I look for the value 10 years from now. Because the business is making money every year. It doesn't matter what's happening in the market. It's like, okay to understand. And then the next question is like, okay, oh, but surely like the people's feelings right now, like when you say like, will it get worse before it gets better, or get better before it gets worse? And it's like yeah, it must be like Christian. There's something that makes it that big.
I feel like I hear this is very motivating.
It's in Elon Musk.
Oh, that's
He's like, look, if you care about our stock prices fluctuating, we don't actually need your investment, okay? So just like stop asking, we don't care. It's like it doesn't even give you a reason to buy. It's like I'm kind of sick of answering your questions right now. It's like so what he does is like your questions are really boring. I think I'm gonna stop answering questions. So but there's other people that need to ask questions. So then it was like another person in line. So he can't come up with that other guy. And this like random YouTuber who's like okay, you want some fans or something. So I'm asking questions and he wants to answer them. Oh yeah, it was pretty fun. Yeah, so there's two approaches to that. So Warren Buffett apparently is like, yeah, you read that book, Making Friends and yeah. Yeah, so he took a course from that guy, Dan Carnegie. And so it was all about like, so like, you know, like you make a list of all the things, like you see someone in your life, you know, you make a list of all the things that you like about them, and it's like, well, you could actually have, you could try to have those attributes, you know, or like you see someone you don't like, you make a list of all the things you don't like about them, and then maybe you don't have those attributes. And I think he really like pulled that off when it comes to his public persona. But my gosh, it's like years go by, he gets so old, he says the same stuff, and no one thinks. So he just can't remember. He was saying like, you know, once someone understands the idea of value investing, like you just basically buy pennies for like $5 like there's something about that idea that just instantly hooks people. Because like if you have to explain why it's good, it's basically you're never gonna get it. Yeah. Oh, he basically, I mean, he just buys it. Like, but I mean, he got lucky too. I mean, it wasn't just all good. So at some point in his career, he went all in on Coke. Coke, yes, yeah, and that just, yeah, so, yeah, so apparently his worst stock purchase was Berkshire Hathaway. That's like his company. Oh, okay. So like, it was like this year or something. It was like going broke. And then it became his holding company for all these other areas as well. Yeah, like that's just brokerage fees. Like it used to be so bad because the broker gets like that percentage and that's the whole point. So they want you to buy and sell a lot. It's like the casino as well. The more it's exchanged, the more they make, it doesn't matter if they're broken or not. So like that kind of stuff is really hard to estimate. So you don't try to estimate it. So he Yeah, if it's way lower, it's like, oh. Yeah. So he has a pretty good track record. I mean, in the financial crisis, he was fine. He's like, and he could, like, I mean, he could afford to buy stuff. He could pick up some pretty good ones. Like, he basically picked up, like, Golden Sand. It's like, it's like the biggest investment on the world. Yeah, it's like, it's like, if you, when you go to these places, you'll know that money is moving. Like, it's like, oh, I used to count money like this. But really, it's like, fraud. It's like you think, oh, it's like, okay, if I need to make this much money, this is my alley, I need to work this much. It's like, but these people, they just print it. It's like, it's not fair. Yeah. It's a pretty funny fucking thing people about.
I want to do get my private note
Yeah. Yeah, and the most common mistake is the liquidity rate. Like, so you always invest in more than you can afford to. Right? Like you always need a certain amount of cash to live. Yeah, to do basic things. So, like, you know, people complain they lost their life savings, you know, they broke and they get about $1,000. It's like, so if you can't afford to basically lose it, you know. So apparently it was such scam in the Philippines, or Malaysia or something. All they did was call people ask their life. And you know, they had some pretty basic standards. But like it worked. Like they got like billions of dollars in Australia. It's like mostly these kind of retiring people.
like one thing what was but today like I think
Oh, I usually doing an investment instead of money work for you and they're not doing anything. Yeah. Yeah, I'm not some realization like money, but they essentially use the trust. That's what we want to do. You know, right? It's like if you trust me, right? I could borrow money from you. Yeah. So that's like I've created money with trust. You know, it's kind of like like I'm giving you a piece of paper and you're trusting me and it'll get you to do it. So that's it. Because what's interesting is they can represent more than like the leverage. That's kind of one of the most the first interesting um discovery about it. So before what they did was they had like you know this like everyone could take on yeah. And so like you just transfer gold to each other. And so like at some point it's like instead of taking the gold out and transferring to people, you just give people deposits on it. So they don't have to get the gold. Yeah. But then if you do that, you don't need to have as much gold as there are. You could just like you can go on average how many people use the gold at a time. So then, yeah, then you can start learning about art and stuff. So you don't have to make that. Yeah. Well, you won't even imagine the savings from one. They just think it's zero. It's unimaginable.
I think also it's more if everyone wants to be old.
Yeah.
Even if it's like
like, well, yeah, and then it's insured, right? Insurance, yeah, it's that happens. Right? And like, well, if it can't happen, then why is it insured, right? Yeah. So that's amazing. Yeah, and it's possible. And then when it happens, it's like the insurance might default as well, right? Oh, this is quickly funny story. So there was one guy, it was like the movie was on the bail. He was like acting as the investor. So there was one investor during the financial crisis. Before the financial crisis happened, he started like buying these. Basically, he started betting on the housing market crashing. So like it was crazy, man, because like, the whole point of it was the housing market. So why would anyone bet on it? Yeah. Okay. But like there's nothing to bet on it, but there's nothing to bet on in a risky way. Yeah. So he was betting a lot of it. So he was in charge of like the two things. And then I was like, oh, I want to bet. So he was like, oh, so let's not, it's like the product doesn't even exist in the bet. I'm just going to make a deal with the bank. Okay, well, so this is Wall Street. You give us free money when you take it. Yeah. Like, oh, okay. So then they're like, the bankers are like, the Deutsche Bank are like, oh, so shall we put $1 million on it? You know, so it's like they're trying to get as much out of them as possible, right? So like $1 million. So like so basically you have to pay $1 million. If the housing market collapses, then you have to get like 30 million off. Like 30 million. Yeah. So then he's like, make it 100 million. He's like, oh, no. Then like, yeah, and then it's in the movie, like the bankers, like they're partying. They're just, right? And then they're partying, and then the other bankers are all there partying. And then they're like, why are you partying? It's like, oh, why are you partying? You believe some idiot walked in and bet $100 million on like the financial, the housing market crashing? Really? Some idiot just walked in. So apparently he bet like $50 billion almost with all the banks. and then like say the main investor in his fund is like, what are you doing? It's like, oh, in the investment agreement, like I'm allowed to manage the fund how I like. And then he's like, yeah, but we didn't think we were gonna turn into a crazy idiot. It's like, I want to pull my money out now. So like, and then he's like, well, luckily there's an agreement in our investment for the can't pull your money out. So like all the investors couldn't pull their money out, and they're all suing for investing their money into this. Yeah. And like the crazy thing was, it wasn't just a bet that he had to pay if it didn't happen. Because like otherwise they just wouldn't. They had to pay a premium to even have it alive. It's like an insurance premium. Okay. So he had to pay like $50 billion. He had to pay like 10 million a month. He had to pay 10 million a month until the housing market, right? And so it's kind of crazy, right? And then he's like, well, it hasn't happened yet. You know, and then people are going crazy, and it still hasn't happened yet. And then like after like a bit longer, it finally starts happening. And all the people, and then some people start investigating it because they're like, why are you trying to do this? Like they started realizing, like, oh crap, like even like the bartender has 3 houses. This market, this like all fun money. How did that? Also, basically, the bankers just stopped checking people at all. They wanted to borrow money to buy a house. They just gave them money to buy a house. And so, like, you know, like the risk associated with people not being able to pay that back. Like, they just assume the housing price will increase to cover the payments. The value of the house will keep increasing. And that increase would pay off the house. It's a bit difficult. So these people who didn't have like income to buy, buying 2 houses, property, and then they're buying off to you have 3 houses. Yeah, and so like the housing market finally crashed, and like people who wanted to do their money still want to put their money out. So the good thing is like if they actually put their money out, the sky would have lost all the money. You know, all the premiums, so they're paying a month for the money. That's a good thing that. Once he paid that, he's like, he just felt like, yeah, 30 times more than he invested. But then he didn't need anyone else's money anymore. Yeah. So every once in a while you hear about this guy, he's like, a few years ago, like, starts flying farms. Yeah. Yeah, exactly. Yeah, like if you do it, it's like, are you saying Tom Greenspan is wrong? Like, because that's all their argument is. But the time, he said the interest rate, the government is correct on the island. It's like, well, it's like, I don't spend any of my time thinking how to work people over. I don't spend any of my time basically dealing with people. Okay? I don't know how to work people over. I don't know how to see people. All I know is how to analyze these figures. Okay? And when I analyze these figures, it's telling me that this is the most obvious thing to do. So therefore, I'll that is wrong. And they're like, okay, I don't think that is wrong. Yeah, that's yeah. Like statistics and statistics and analysis is like one of the things we want to find out but then they follow along the movie. But yeah, statistics is probably the single most useful thing out of but it's just like it's way much easier. Well, when you mess up with it, it's really like so they get more yes, I guess it depends on what you find. I really started finding it interesting. Well, the ideas of it is difficult. That's why it's so exciting. They're really interested in how well they explain them. Whereas some things are interesting just because they so what are the options? Possible question two, possible question one. That's one option. Oh yeah, do you want to go through the question one?
Oh, yeah.
Oh. All right. All right. How does it go?
Let's go. Well, they'll just like state the bijection and prove it.
Yeah.
works.
Let's do it.
Okay.
Oh yeah, there's like an even better. I think there's like an even easier way of explaining. There's like a real easy way of there's an even easier way of explaining how it works.
Oh. Well,
If you just draw it out,
just like the forecast.
yeah.
Okay.
How many? Do all of them? Or few of them?
Just
one
one
of
of them. Yes. So it's like okay. So let's go this one. This will be 2.
Yeah. So n equals 4, and then you have like r plus s equals 3, and
Mhm.
2 and plus 1.
Okay.
So that's 2 above the diamond. You know.
2 of that. What's the idea?
So yeah. So if we take a look, so right now the stuff we count is like we count all the stuff on this side,
Yeah.
and then so if we want to bijection, we want like another group of we want to be able to biject like the rest of this onto that side. So if we just ignore the bottom one. Okay, so it's going to be something to do with reflection, which means that and since it's this diagonal, we're probably reflecting about this diagonal. And then if we notice that anything on this row here, on anything on this row here, when reflected, will definitely not be in here.
Mm-hmm.
Which means that if we were going to do if we were shifting this downwards, this row we can just ignore the bottom row. And if we look at it, here we actually have one. The number of squares here, and is actually equal to the number of squares over here. So then, and the total number of rooks in this part here is going to be equal to n minus 1.
Oh.
Which means that anything that's not in here has to be in this part. Which means that what we want to be doing is we want to be moving this part here onto that side. So what we can do is so the idea before was to first shift everything downwards and move this row up to this side, which gets us
Oh, Edwin says I already wrote out question 1.
Oh. Right, so but the thing is now is when we look at this part here, this part is what was here, what we wanted, and now this part perfectly reflects into the other side. So that means And if anything was in this part before, it could only get moved to this diagonal, so it cannot be in this part. So anything that wasn't in this part will be in here, and anything that was will still be in here. So now what we can just reflect this that way. We can reflect this about this diagonal, and then everything that was here is now here, and then everything that was here is now either on this line or in here. So then and since we know that we said before that like the total number of books in this part here as to like n minus one, then now the amount like the number of books in after we flip it is just adds up with this to the n minus one.
Yeah.
So we're just taking this part and moving it here.
Like this part goes to here.
So we move it all down, and then makes it into
Oh yeah, so like another construction you can do is just take this part and rotate this whole part 180 degrees. Yeah, and it's basically the same idea. And if it's symmetrical, then it'll be so fine because if it's symmetrical, then they add up to n minus one. Then they're the same thing. So so like if they're the same, right? Then it's a bidirectional to itself. Like
that's fine.
But if you rotated the things on the diagonal.
the things on diagonal.
So just
So you
rotate
rotate
the
the
top
top n by n minus one.
Oh, okay.
and then
It's the same thing as this, except with this one you're moving this up.
Oh, no, he's saying rotation of this part by 180.
and the top.
To work on the bottom left square.
Bottom left.
Oh right.
What?
So he's
if you have a rook on the bottom left.
Also,
No. So okay, you rotate the top one.
Yeah.
And wherever there isn't a rook, you just move the bottom rook up. Because what he's saying is because there's only after you rotate the top, there's only one place where the last rook can be, so it's fine.
yeah, so there's only one.
Right, so we have
So-
two bijects. So one is like you shift everything
Down one.
mod 4, yeah?
Yep.
And then you reflect about the main diagonal.
Yeah.
And the other alternative was to remove the bottom row, rotate 180, and then
And there's only one spot for the last rook to be.
I see. You're doing it so it makes sense.
Yeah, because just in case that like if that's
You gotta keep it pacifist. What it was called? Peaceful. Yeah.
I think like
Oh,
the
and
location
so-
of the bottom rook is just
Yeah, so-
reflected across the midline. Might be. If it's on,
Yes.
it's weird.
Yes.
If it's on, it's weird.
No. If it's on and it's in the middle, it's
Oh,
all
right.
yeah.
It says okay. That's fine.
If you have a tool on the bottom, that's great.
Watch out, this is like chess.
I guess you can say like so reflect the bottom line about the midline and rotate the top one 180 degrees.
Yeah. So I guess n equals 4 was the one that we had a lot of things.
That's the first one where the cases actually sort of
Mattered. Yeah.
Are we good for that?
Yeah. This is like
Alright, so I can take this.
I'll just hand you like some of the bottom.
I'll probably just hand in like a few of one from each one.
Why?
Like more like the ones that we've sort of done. Because if all of them are like
like this bijection, I guess. I can just find out. But like if for the other ones, if it's like helped by someone else, if all were helped by someone else, it's kind of lucky.
Yeah, well, I guess out of the 5 exams, I mean, essentially 2 or 3 of them are kind of, they're no longer what they were intended to be. You just don't have enough time.
No.
Should we try that?
Which one?
S3 question 2.
Oh, that's geometry. Okay, geometry, I'm kind of out of the picture for this. Geometry.
Oh, okay, yeah, I see. It's not. It's kind of alright, I guess.
Do you want to brainstorm it?
There's 3 circles.
3 circles.
Yeah.
Does anyone want to draw the circles on the board? Anyone want
Oh, yeah.
Okay.
to? This time we can make use of our colored pens.
We should probably draw the insert first.
Okay, let's just brainstorm S3 too. Yeah.
Yep.
No blue pen here. We have a red pen somewhere. What happened to the red pen?
Red pen.
We just never had a red pen.
I've been using it for last year. I was on black. Okay. So we have
Shall we start?
in circle.
So this is S3 question 2.
This is how I'm gonna remember the solution to this question.
Ah.
I wonder how many points you get for it.
Maybe like 1 for the construction is correct. If they can interpret what you mean.
Yeah.
This right isn't working. And you're like, oh, we had an idea. So, circle. Okay. Well, sort of circle. Circle.
Well, like the equilateral triangle.
Yeah, it's a bit.
So that ABC right there.
Yeah. So this is oops. Circle center A plus.
Oh, okay.
Tracking with pencil.
Intersects the circle one side.
Okay.
And prove that this is a tangent. Prove that it actually looks kind of tangent. But no, okay. So it's tangent to the circle. Okay. So, if proving something is tangent, I don't think it's.
It's probably either it's either alternate segment or
Yeah, but
again it's
we can't just assume that it touches at one point. It's not touches 2. So
no, it's fine.
if we just assume it's tangent first, and then yeah, it is. Doing all that today. Did that for Q1.
Yeah.
But yeah, assume the result first and prove it positive.
You didn't believe in it before, and then I did that question.
Yeah. And now it's like what every problem is doing.
Yeah.
Now.
That's what I did before, and then people told me it was called reverse reconstruction.
It's actually the most little ever. Alright, so yeah, I think it's quite annoying for tangents to prove it's that because you can't just say it as unless we can sort of like sense what point it is and just prove it's that.
construct it in circle, make a isosceles triangle. Or any other.
Isosceles.
Word tangent. Wait, so what are you suggesting?
I think we just make MN a tangent
Yeah, and then but it has to be
and then prove that.
equidistant from A.
Yeah, MIN as circumcircle A or something like that.
Yeah.
I think that's fair. That's not bad.
So you just make them like equidistant from A.
Yeah, we make them equidistant and prove MIN is like something.
Yeah.
What something is that? Something.
Yeah, use reverse reconstruction and mix it down on the last question. And then solve this one.
Alright, so if we assume that, let's like make the tangent point B. So it's D. Okay.
Like a reverse Charleston.
Sort of. Interesting. Does M look like a C Charles point? Does M look like the Charles point from C on like your scale diagram?
Hang on, figure out that's what you want to do. Unless you want me to draw that way.
So you draw the circumcircle and then just draw some random line. No, just measure. You measure AI. Essentially, you just like do the same thing to draw the number.
It doesn't really like
No.
so look it's like here.
It is one true for the other.
Oh, if you can prove it, it's kind of really good. And look at this.
Yeah.
So
Let's see.
go up here. Is the center to here is perpendicular to the inside. Because this is perpendicular. So
Yeah. Like what?
Yeah. So center to here, because this is isosceles triangle. Because well, you need the street for this, so you need the tangent. So you construct the tangent such that this is isosceles. Yeah, which means it's perpendicular to OA, which means that and it's also perpendicular to this point. Yeah. So I think we're going IA. Yeah, then the need for I think we're going to do today.
So Edwin asks, are we trying to prove that A is the center of MIN?
Yeah.
Yeah, yes, that's.
for all non-focusing with the incentive and the center of the configuration. So this incentive is like X center. What's this? So, yeah, that's how we set it up. Would be nice if we could be doing everything right. Okay, so this is the 2 bisect It's not bisect these two. This we probably be careful with the bisect. So it's not this. This center and this isn't the this isn't the one so there's no point going that one to the same as this one. So how would we do that?
Are we trying to prove it's tangent?
Well, we assume it's tangent.
We assume it's
So we're
tangent.
going backwards from the solution.
But the ultimate conclusion is it's tangent to that. The MN is tangent to the circle. In the circle.
That was the question first.
Not even that.
Do we know anything about inversion? I'm just,
Oh, right.
I guess I'm waiting for the time we're going to use inversion or something.
I mean, we get a 10.
So how does the inner circle invert?
Everything is pretty circle.
So would you invert with the circle in an A?
Is that A or
Oh,
maybe?
it's interesting because we have like
Wait, so if you invert MN, right?
there's no tangents, yeah.
If you invert MN, you get ABC.
And
MN inverts like the line MN, yeah?
Oh, yeah, you do.
Inverse to the circle ABC.
I'm not too confident about it. But do we know that? Oh, because
It has to invert to a circle. Passing
Yeah.
through A and M.
A, M, and M. Yeah. Why is it possible A?
Well, because lines that don't go through A invert to circles that go through A.
Sick. Okay. What does that mean?
So that means if the,
Oh, and
what is the in circle invert to?
Encircle A was to another circle. It should be another circle with the same number.
Huh? As well?
It still has the same like vertical axis, like with the circle A.
Very glad to be circulating.
Because it should pass through those two second points.
So then it just becomes. So that circle should now be tangent to the ABC circle, right?
Where the A circle passes through the center of the circle. In center.
Oh, that's important.
Does that mean something?
Do you what?
Because I don't know what that
That
means.
should mean something. Wait, so A.
That should mean something. Yeah.
Okay, so
That's why we do it.
so the circle passes through the center.
Okay. So inverting the circle. Yeah. You can't visualize what that means. Yeah.
So I mean, the inside should come outside. The
Yeah.
outside should go
Outside
inside.
goes inside. Could it go to itself? Or is that just no?
So if it goes to itself, then it won't be tangent. So what do we know about circles again? That if they're not going through A, they should go to circle. Is that right? So it should go to a circle that's tangent to the ABC, right? Somehow.
Tangent to circle ABC.
Yeah.
Okay.
So is there a point on the inner circle that matches to? So it's the tangent point is meant to match wherever that tangent point.
How do we know it's tangent to circle ABC?
Oh, because
It has to be.
so MN is if MN is tangent to the inner circle, right?
Yeah.
Then the inversion of MN
It's also tangent to the inversion.
should be inversion tangent to the inversion of the inner circle.
Oh, right. At point A. Okay.
Oh, so I guess it's possible that. So if it has a second point of intersection, okay, it could be an A, but so it goes through A,
How
right?
can it be tangent point if like the circle ABC doesn't even touch it?
No, not circle ABC. MN becomes.
Does it MN become ABC?
Yeah, MN becomes ABC, right?
Yeah.
And then I becomes this inner circle becomes another circle that's tangent to ABC.
Is that at point P or no?
Oh no, it's on the circle, on the big
But
circle.
it would be on here.
It'd be the image. Of
Oh no,
Yeah,
yeah, big image of it. Yeah. Somewhere.
Oh wait, and circle circle ABC just goes to the red.
Yeah.
Yeah, so just like
So those two.
those bit don't change. Yeah.
Oh yeah, that's what Johnny was saying with Johnny and Bernie. He said you know, it's like stuff. He said if anything, like he said like Charles' point, he's put a Johnny inverted point because if you invert about that point, the line becomes like the line becomes a the circle and the line and the circle becomes that line. So
Oh, okay.
So if the centers are A and I, right? Oh, I'm getting confused which circles which. So if you join A to I,
Yeah.
oh, so the tangent might not happen on that line. But the tangent might, like APIs might not be doing it.
Yeah.
Well, that's the I, right?
and rays become themselves.
Yeah, so if you join A to I,
So basically,
I is a fixed point.
basically everything is like still there, except B and C can close them. But you know,
Also, in the circle. In the circle.
now AB becomes on the line, and then
AP,
becomes like the intersections of AB and AC with the line.
Huh?
So when you invert it about, because the circle ABC becomes line MN, right? Yeah, and then it the B corresponds to the like point where it's 60 vertical axis. So it's like B goes to there and C goes to there.
oh,
What?
So B goes to there.
Who goes to that right there? Oh, because the circle goes to M.
Yeah.
So the intersection goes.
Yes.
Okay. Okay. What if we like construct the point opposite A on the circle? Because then A will be the Charles one of that.
What?
Well, yeah, if we draw AI and it makes the circle something, and then that's something, we have Charles one of them.
You have two Charles points, and then
Because A is the Charles one of something.
oh, wait, hang on, is that genius?
So you draw AI to hit the circle.
Yeah, and then you put the other side.
or you mean invert about another circle.
No, I think inverting around MIN is correct. Because that keeps things the same way.
Oh, wait, Jordan, come look at this. Yeah, so I did your thing, I used this over here. And I draw another triangle. And I connected with here.
Yeah.
And I see what the inside wall
Oh, does it code? Does it?
Yeah.
Yeah, and then they all be transformed.
Yeah.
So
So
it
it's
is like those are true.
all right.
But that's not the
That's my
that might be
that's
the
okay. That's a beautiful idea.
yeah, that might be synthetic.
So if you join AI into your new here,
Yeah.
Because we have, well, we're trying to prove that. And then there's, okay, this is no longer inversion.
and then
It's
if you
also
connect this
very
to here and just the I, this seems like an instant of that.
It should be right, because that's what we're trying to prove. We're bringing that AI.
This should be the this circle should also be the instant of this.
Oh, this right.
Oh,
Because
I
A is
don't
just
know why we call it
Charles
M,
Bond.
but that's okay.
It's like view. Okay. Yeah, we already have it there. Nice. Which is interesting.
It looks
That might be an
it looks very true on my level.
no, it should be true.
Yeah. Yeah. Okay. So once we build this right, because this is the angle bisect here. This is correct. This
Yeah. You can
It
probably
is
change
all
it
because
down.
it's- Yeah. So that's definitely you know we just have to do it. So,
But if you do that, are we done? Or,
yeah.
So I would be like something that would be an easy choice. Okay. So, okay. This fits the other bit.
Yeah.
Because we don't have this.
We don't have anything at home.
What is the second? So then this angle will be there's a whole yeah. And this. And then this will so we have to prove that one. This something that happened. No. Because half of this time is just businesses. Because it is a sacrifice. Oh yeah, I'm trying to put it in sentence. So this is
So we know that this is angle bisector, right?
yeah, there should be because yeah, there are big blocks.
Because these are the same, yeah.
How do you get that dot?
Oh, this is radial.
Oh, okay. So we don't know that yet.
No what? Well, we know these two are equal.
Oh, why?
Because of radial.
No, we're trying to prove.
Oh, we're trying to do it the other way.
Oh, you're doing it the other
Yeah,
way.
we assume that it's tangent. So, we prove that it's the same.
Alternative without with that we could try that later.
We'll try that.
And like start with this and make sure that this can be like this.
Oh, yeah, that's true. Yeah,
There's a origin.
oh, so you have what? Take off of that. Yeah. And do the same process. And this will be one of the next one. And then so we have that'll be one of the next.
And flip cycle.
Well, no, the swap would be. So this half. So 180 minus this half should be right. So this would probably be oh yeah, this would be interesting. Oh,
But do we know that's the center of the glue or not?
we're trying to prove that. So we have one angle bisector, we're trying to prove that. And I think because it's like sort of symmetric, Either way, we prove that it's another angle bisector if we connect one of them, or we can prove that MIN equals to 90 plus like half of MUN.
Right, yeah.
Yeah.
We got like, so this is what would you use? This was, what would you say this was? That's 180.
Oh yeah, this one is 2 dot.
2 dot, right? And then yeah. That's half.
Oh,
That's 90. That's 180 minus half of this, right? So, yeah, half of this was this.
yeah.
Oh, wait,
wait,
is it? Yeah.
No, it's 90 plus.
Wait, it is, right?
Yeah.
This is
Is that enough?
I think that should be enough.
Oh yeah,
Yeah, angle bisector
yeah.
at 1 point.
Yeah, so
Oh wait, nice. Alright, how do we do this again?
so we got these 2 dot. This is 180 minus 2 dot.
get 180 minus 2 dot, and then we
And then this plus this will be minus 2 dot.
this plus this is 180 minus 2 dot. So it's wait.
Oh, because the second place. So so these two big angles, this one will be minus 2 dot, this big this plus this, and then we take half of that, that'll be 90 minus dot. So some of these is 90 minus dot, and some is 90 plus that, and then we're good.
But we assume that was the inside. No, because yes, we did. Yeah, we did. So go on. Yeah.
That is also true. Okay.
So what are you guys trying to prove right now? One of these is angle bisectors.
Yeah, something like that. We're trying to prove that I is the insector.
So like
So I can prove that one is an angle bisector, or we can prove that
this one is equal.
or we can prove that MIN equals to 90 plus like one of these. So this angle is 90 plus one of these, which looks more like correct to do because it's symmetrical in a sense. But also,
How about we
So do you know that MIN line is circle?
yeah, they should run something.
I mean, if you have like this angle bisector, right?
Yeah.
That passes through I and A, yeah?
Yeah.
And you know these lengths are equal.
Yeah.
And you know, if you know that this length is equal to those two lengths, you know that that has to be.
Yeah.
Does that make it the incenter?
Yes.
yeah.
Huh?
Yes.
Yeah.
So just knowing this length is equal to this, you know that this is the incenter of M and that is its.
And you have Q.
So that's what we're trying to prove. If we prove that I is the incenter, then we get the left should be equal. So we could
Doesn't wait. So if you take it, doesn't that prove it? Like, so if you take a circle, right?
Yeah.
That passes through A. Let's center A. Passes through M and I, right?
Yeah.
Then these would have to have the same distance.
No, we start with
We start with the other condition.
we start with M and tangent. Okay.
Oh,
So right, yeah, we don't know that it's a circle.
oh, you don't know it's a circle.
But that circle's kind of above. There's no boundary. So we're starting with its tangent P, and now we've got P trying to prove its eyes to incentive of MQ.
Oh. So
And QI being so plus
Extend this to this. So that's
yeah.
more if you prove it, then it's the same thing as what we did here. Because we're doing this.
wait, hold on. So if you have the circle, right? If you have the circle, before you have this tangent,
Yeah.
would you have that? This is the incenter of. Oh, but it might wait. So it could be the incenter, but could it be a different incenter? If it was the same incircle,
Should be the same answer.
should it?
While the inside
I mean, like, are you saying that? So the incircle of A, B, C is the same as the incircle of M and Q. Oh,
yeah.
then wouldn't
Does
that
that change if we don't start with the tangent?
So if that was the case, then it would have to be tangent, right?
Yeah. Okay, what if it's what if it's
Start
not
with the other one. How do you figure out the in radius? How do you figure out the in radius?
Do we need that?
Huh?
Do we need that?
Well, if you knew the in radius was the same, then it would be the same circle.
It should just be the same.
Is it obvious?
I'm not sure.
I mean, so we're not assuming it's tangent, right? We're just assuming it's.
Yeah.
So assume there's a circle.
Yeah.
Don't assume it's tangent.
No.
Get that point, right? Then once you got that point, you know by your lemma thing that these three equal. Is that your lemma?
Yes.
Yeah, so because it's on a circle, they're equal. And then that would make that the incenter of M and Q.
Oh, yeah.
Yeah.
So if it was the same circle, then it would be tangent to M and, right?
Oh.
So that's just the side of a triangle. Oh, if you guys didn't do
difficult to like visualize right now. So I'm gonna see the diagram as it's being drawn.
Right, so is there a relation between the in radius and the circle radius?
You can express them in terms of like the subgroups. Yeah.
So are they
And here,
oh, yeah.
Which can be expressed in terms of vessel.
Right, so okay, so the two triangles have the same circle radius.
Yeah, and ABC is the triangle ABC is fixed. So yeah, in radius is just like A plus B plus C over S. Not that. No. It's the area of ABC over S. And that doesn't change. So in radius is the same.
So the area of ABC is the same as the area of QMN.
No, the area of ABC is constant no matter what assumption you start with. The triangle ABC is constant no matter what you start with.
Yeah.
And in radius is just given by the area over the semi-perimeter.
Yeah.
So in radius.
Yeah. Wait, so I'm trying to say that the in radius of like I feel like there's two triangles, yeah, ABC and QMN. The incenters are the same.
yeah, eventually.
And I'm trying to show the in radius is the same.
We don't know if the
Wait, didn't we just show it? Well, it depends on what you assume. If you assume that it's a circle, doesn't that mean the incenter is the same?
Yeah. So it's really, right. Okay. So yeah, it's nice. Yeah, it's nice. Good one. Let me see. Let's go on. Okay. Where is that? Is that your key? Yeah. So you get your key. Yeah. You draw a triangle, and the right side happens to be an HDR. Oh, yeah. Okay.
So we said that this and this, but
So we should have that equal
Put some formula. Okay, good.
So we extend it. So how this is.
and then
Given the assumption that because we know these were equal,
Yeah.
just extend this here. This should be the center.
yeah,
Of Q1.
yeah.
This
was
is
the
also
one.
the center of ABC.
Yeah.
Yeah, that's how that's how it's always something.
Yeah. So this is the formula.
Oh.
So there's a formula that says the distance between the circumcenter and the incenter squared is
Oh yeah. It's equal to what?
it's equal to
R squared minus 2R. Which is cool. This can also be like the power of the point of the incenter. The circumcenter is always 2R.
d squared equals what is it?
R squared minus 2 small r bigger.
So that means you can express little r in terms of these other things, right?
Yeah.
Yeah. So r is the same for both circles.
Oh.
So
we know that. The same in circle of both ABC.
Well, we were proving it the same.
But yeah, all of a sudden with a different assumption. Doesn't that do it?
Yeah. But then we know it's the same in center, but we don't know it's the same in radius.
Isn't it the same?
But now we know it is.
Oh,
yeah,
okay.
there might be a simpler way to say it, but you can see this formula, right?
Oh,
You know, r is the same.
R is the same, D is the same,
D is the
Yeah.
same.
and R, P, R is the same.
okay.
Alright, I guess that's all.
So that makes sense. So what does that mean?
So it's the same in radius. Which means that this is the incircle of this one.
Yeah.
So
So
that is a tangent.
the incircle is a tangent to the triangle. Yeah.
Alright, I'm just going D equals R, D squared equals R squared minus 2R D cubed.
Was this the first time we really used? Well, we didn't really. I don't know if we used PowerPoint, but we used. The theme was PowerPoint. Right?
Oh, practice.
But this is the power of
The
r.
power of I is to R. I tried to use
It's
that.
the power of the incenter.
Right, is
The
it?
power of the incenter and the circumcenter is 2R.
I think you know.
Because the definition of power of a point is distance. Is it radius squared minus distance squared, right?
2R is power of one.
Yeah. So
Well,
2r
yeah.
equals r squared minus d squared.
Uh,
No, we took a while to show.
yeah.
You can use some trick for it.
I think it had something to do with the author center. Did it?
Yeah. I prefer using trig ones, and then I found like a synthetic proof and I forgot it. But the synthetic is a lot. What?
This is synthetic free.
We went through it. We have it on video somewhere.
When you like, if worst comes to worst, I guess that's enough.
It was one of the metrics.
No, actually, it wasn't the author center. It was just using the eyes instead of being perpendicular to all the stuff in an angle shape.
Oh no, I think you use Charles as well.
But you know, this doesn't mean it's the end. It could be the starting point. Like now you know it's true.
Well,
Like now we have like a sort of inefficient proof, I guess.
Yeah.
So yeah, so if so, I guess this is how what I'm thinking goes. Okay, so you have a circle, right? You draw the other circle, yeah, and you draw MN, yeah. You point, as you said, put point Q there, right? Okay, and then you know that the incenter of M and Q has to lie on QA. Yeah?
Yeah.
Because we proved that this was angle bias.
Yeah.
And I guess we did that because this is a radii. Yeah?
Yeah.
Okay, so internet has to lie somewhere there, right?
Yeah.
Well, then you know that it has to lie where this length equals that length, right?
Yeah. So it has to be that point.
It has to be that point.
Yeah. So that's the incenter.
That's the incenter. And then you know the in radius is the same.
Yeah. Yeah.
Maybe there's an easier way to know the in radius is the
Yeah.
same. But if you know the in radius is the same, then it's obviously tangent. The in circle is obviously tangent to the triangle.
I was not sure inverse.
I guess also for the construction, we just going to prove it is they construct AI to Q, and then say that this equals to this by Charles number, by converse of Charles number. Yeah. Yeah. Can't quote
That converse or just like straight across?
well, it's converse rather than if this is that, then this is
Oh yeah.
and I'm pretty sure it's kind of the same way.
Yeah, I mean, there's only one point that's equidistant, right?
Yeah.
Yeah.
And that's
Uh-huh.
this Charles number of
Well, did they say it's not quotable?
Charles lemma is not quite.
Well, you can't call it Charles' lemma.
Yeah,
I can tell you that much.
It's want to make a point of that.
Yeah,
It's like,
yeah,
oh,
but
actually,
you actually need
it's
to call it, so that's why they teach you how to do it.
Yeah.
Oh,
It's
so they don't
not-
just
it's
tell you
not
the proper name of the lemma.
Yeah.
I'm pretty sure if you wrote the proper name of the lemma, it becomes quotable. I don't know, like, it seems like the US quote everything.
Yeah.
They're like, their
Yeah.
proof is just 5 names from people. Like, they never actually use maths, they just use names.
Like by this, yes.
Oh, yes.
Yeah, there's like 7.
But
On the
also,
they was a
range
five
theorem.
mathematicians.
But they was one market to do put a full scale diagram on the front page.
Yeah, then it's not geometry. It's just like name chasing.
History,
Name chase.
name fashion.
You can probably, like, there's probably some mathematician who you could be like, oh yeah, by Euler's theorem. Then that's like, you know, it's like, oh, he's probably right.
Yeah.
Which like you didn't specify which theorem.
Wasn't in the letter, so some ex-mathematician in 1850.
And 9 o'clock p.m.
Uh,
on 13th February.
I'm still yet to invert.
Yeah. We can try finding an inversion. This looks inversionable.
Inversionable.
Because MN goes to circle
And
and vice versa. Yeah, which is
And-
nice.
yeah.
So it should be invertible.
What does BC go to again?
The 2 points on MN.
2 points on MN that where AB and AC used to go to.
Okay. Huh?
Hooray.
Hooray.
Yes.
Oh.
What have we done? We pretty much solved it. Yeah. What we could do that.
It's like, this is what it feels like to be ahead. I've solved it, now is the best way to solve it.
Well, if that probably wasn't inverted isn't necessarily the best way to solve it.
Huh?
Probably inverted isn't necessarily the best way.
I know, but it might, in the search for the best way may involve the investigation of inversion. So it's like, I don't know if you've ever been annoyed when like you can't solve something and someone else is trying to solve it a better way. That's also like
Where did everyone see it?
There should be a better way to prove that they're the same and so.
The side lenses.
You add up the side lengths.
Is Edwin in agreement? Are you with us on the solution?
It's not
Or are
true
you
bashing
against
itself.
us?
Yeah.
It's totally better.
Huh?
It's not trig bashing.
To find the side
You
lengths.
use trig to find the some size blades.
You provide a short, complex dash to determine sometimes.
And then after that, you give the system weights on the same side. The sum of side weights on the same. You can complete it in the same.
It says Euler is fine.
Mm.
You know, like polygon.
Mm-hmm.
The triangle is a trigon.
Oh.
And that's trigonometry.
Oh.
You didn't watch the video. That's why I asked
It's a
this.
test.
It's always a test.
Quadrangle structure.
Don't worry, it's all there just in case you want to fill up your gaps.
Oh yeah.
But not before this test, okay? You can't learn anything that will help you. It's just pure conditioning from now on.
Oh yeah, that
Well,
yeah, we don't do AI anymore. I wonder how the rest of the people. I wonder how the rest of the people do AI.
Yeah, so I feel like Sean would have a better chance of seeing your contents in AI mode.
Yeah, he writes out his and then he like takes one time.
Yeah, the time is a trouble.
I mean, like most of AI mode, even if you like, well, I'm pretty sure last year for the first 8 questions, I proved it. Like it's an algebraic quiz.
stop last year because I had calculation. It was the triangle one. When you did angles on the triangle is 90 or something. I wrote down the wrong answer.
The angle someone will try.
Oh. And I didn't get mine.
Oh.
I saw it at mine. It was like, the proof was very handy.
I got the induction for some of it, and then everyone else in the where it's like, oh, it's just 192, right? It's easy.
Oh, it's like it's right 192 on the page.
Yeah, it's weirder when the angle sum is smaller. But it's okay if it's bigger. Like you can get angle sum 270.
Yeah.
North Pole,
Yeah.
equator, North Pole.
I don't like the first part of 10, which was easy.
What through part of 10 was like, yeah, you know the part was like, if and then we right, you just go one way and you prove it backwards, and it's like really trivial.
I spent all my time running like 5 pages of proof in mine.
I
try like 10 of it.
I didn't understand what 2 meant for the first like hour. Like first 3 hours, and then I come halfway through now, and I'm like, oh shit, that's what 2 means. Question 2 was like the buggiest.
Alright, so the one thing I want to do before this completely finishes is what happen. How do you invert the insert? How do you do it?
Circle through transfer. That should be the thing. Or you should come up common. So yeah, it's a good thing. If we invert the insert before the transfer, what happens?
But what happens if we invert about I?
Invert the
What does MM become?
And then becomes circle tangent. Well, it's supposed to become circle tangent. Well, no, it becomes, wait, hang on.
So MM becomes a circle, right?
It becomes circle, yes.
It's supposed to be.
Instead of circle through I.
Well, that point's fixed, yeah.
Yeah.
Or possibly there's 2 points of intersection.
Yeah.
So if there's 2 points of intersection, then you know it's has to be that circle that passes through I.
The passes through I should pass through like either 2 points of intersection or the tangent. You pass through I.
Oh, because lines just go to
Lines
circles.
not
Lines not through I, turn into circles through I.
It is like the point of information. Goes back to something. Okay. And that defines a circle. There's tangent, there's 2 points.
Yeah.
Or it might not intersect at all.
But we should. Oh, right, yeah.
So this is why we assume it's tangent.
Oh, okay. You assume it's tangent.
Yeah, we go from there. Where you go find something.
Oh, then we're trying to say that's a circle.
Yeah. So
Oh, okay.
and then say that's a line.
Oh,
How do we do that version?
that circle should be. Oh, a second.
Oh, and then you just do like if you go to like community or something, you know, something. It's something.
Yeah, like if you want,
yeah.
if you want to invert it to a circle.
So good net like.
But it's like this line here.
Yeah, if we invert the circle through and through circle, they should go through. It should go to the line of the tangent points, not the tangent points. So the intersection points, yeah. And then how do we use that to tell us that is the center? Yeah, it's sort of. And then do that. It doesn't because the distance is very long. Yeah. Yeah, if we wanted to invert, we probably have to go the circle first. Because the tangent series is easier to do. This one, if you want.
Same. I think Sean's coming.
Yeah.
Sean's coming. David shouldn't be coming. I think he's sick.
Oh, he's been sick for like 3 weeks. Yeah, it's hilarious. Wait, he booked still here, right? Yeah, that's true. Oh,
Yeah, and so I'm assuming Edwin might be online again. I don't know.
He not as worried about coronavirus.
Oh no, I'm certain that women are at least 10 times more worried than men.
Yeah, like it's true.
Like not even statistically, it's just certainly.
Yeah,
Statistically, it's probably like
Is your
100
mother more worried
times.
than your dad? Yeah, a lot worried. We like we chat every day and see.
we bought like hand sanitizer. It's like around the house.
Yeah.
It's like you have to watch out.
But I wonder who's made that
hand
observation.
sanitizer off.
Yeah, like
No.
Yeah.
That doesn't even help.
Yeah, I know.
that observation is important. Like, women are definitely like 10 times definitely. Statistically, maybe it's 1,000 times, like on average.
Yeah.
It's just like the sense of smell. Like, you know that?
No.
It's women's sense of smell is like at least 4,000 times stronger, or something ridiculous.
Oh,
That's pretty good.
Yeah.
That's good.
That's why like everything's a mess when it's dry.
yeah.
It's like, it smells bad. It smells.
What smell?
Maybe Edwin figured out to call the turkey again. Yeah, that'd be very good.
Is it online now?
Still winning.
I ate a food shift.
Oh, it's 8:28.
Oh, that's like.
Wait, does that mean?
Hold on. I was like called me 5 times. Oh, yeah, here, but take your time.
Okay, well, we did hang out.
How much time can we take? Because I don't even. Oh, it's alright. Okay, so if it's inverting about the small circle, right?
Yeah.
With in center I.
Yeah.
And then kind of turns into this funny circle that like it's like this.
Yeah.
Yeah.
Oh, yeah. Just pull it all out of here. And then I will have to work on myself to we'll be done. And then tomorrow we'll be just like, and then like Monday we'll just like sleep and that's cool.
Yeah, I reckon like the school should be more lenient towards like it's not like
where you just want to miss school. It's like you have a plan. Like you want to know what, like I want to do this and this and this.
Yeah, the thing is with school, like every other school pretty much, I'm pretty sure the people who go to math camp is don't do shit in class and just do maths. Like where you just like in like how many classes?
I do it in chem and phys.
Yep.
In math.
Yep.
It's math's easy.
Yeah. Yeah, I feel like that.
I was doing in Christian studies, but our teachers like he comes up with okay. Was is like it's not really.
Oh, what's yours? Oh, how do you?
Yeah, that's in the English.
English is the most dodgy one because they look at it like thing that you're not doing the right thing.
This is probably not English.
Because any of my classes are pretty much cut. I can probably do it. Probably can do it in like this because our teachers are very strict.
Yeah,
That's
like
like-
this does not care.
Yeah.
Oh my god.
No, it's really weird, right? Because I'm pretty sure he's mostly aware that I'm not like I know what I'm like. I know what's going on. I'm not actively paying attention. I'm like doing my own thing.
Yeah.
But then and then so like every time, right? Like he puts question on the board, and then he asks a question, and so he picks on it and the answer, and he's like, yeah, that sounds right. And then like typing, do you agree? I'm like, yes. And sometimes I'm like, no. But like, I'm just wondering, why are you asking me? Because last time he asked a few. He was like we had a new science like block opening, and then we had to do like he wanted some students to do some demonstrations with some like new equipment. So then he's like he just asked me, okay, do you need to catch it? Do you have anywhere to go after school? I'm like, no. And he's like, okay, do you want to do it? I'm like, why not? And then because there's food. So I'm like, okay, I'll do it. So I'm like, he's like, okay, all you have to do is just drop just do the thing with the equipment that like I know how to do it. And then so I'm like, okay, I thought that's literally it. I'm like, so are you gonna be explaining the thing on the board? And he's like, oh no. And then I'm like, hang on, let's go wait. And then and I go there and he's like, okay, and then like all the people gather around, including our like, principal. There's science head teacher, our ex-principal. As a retired science teacher who used to be the who used to be the chess life teacher, and some special guests.
Prime Minister.
And they like, and then they all come in the room. And I'm just standing there next to the equipment, and then the teacher, and then my teacher like, okay, go. I'm like, okay, and I just start talking about it, and then like I was pretty much like they thought I couldn't flex about what acceleration was for 15 minutes, but I did. And I just like because basically it's like it converts like analog data into like digital and it graphs it for you on the software.
Yeah.
So then I just like explained that like some random stuff about that for like 10 to 15 minutes. Just like talking about stuff. I'm like, okay, what do I have to do?
Yeah.
So then after that he just like I think he kind of like likes me now, and then so but then okay he taught me maths in year 8, but yeah. So he sort of knows me, and then so now like in class, I just sit there and occasionally I answer a question.
It's
And
weird because like it's like you're trying to explain it to them so they understand it,
like not really.
but like their reaction is purely based on them not understanding it. It's like it's like applying for grants. Apparently, it's like if they understand what your research topic is, they're not going to give it to you because they think it must be stupid if they understand it.
Yeah.
Because they're stupid, obviously. It's like, but if they don't understand it, well, that's some new research happening right there.
Yeah, and then so like occasionally it's like I think do you agree in the middle of the class? I'm just and then my friend's like, why is he asking me? Like, why?
I guess this is one of the problems here. It's like you're voting about I, right? It's like, well, you know that MIN is a circle, right? But the problem is you don't know it's centered A. Is that the kind of thing?
Yeah, I don't know.
And center doesn't
like tell the center.
Yeah, the center doesn't really like the center just changes.
Yeah.
Did we have something about what happens at the center? Do you remember?
What happens to the center?
We had like that was like the last theorem we learned. Really? Do you remember this stuff?
No.
Guys, I've experienced exactly the same lectures as you. Okay? I'm just reading them and telling you what I read.
The sense of
So
those-
when I think of something, I'm like, oh, you should think of it too because we have the same honestly. See, that's why I don't have like. See, when you teach something for a long time, you start assuming people who don't know it do know it because you've taught previous students.
Oh, yeah.
Look, this is the charm of it doing it the first time. Where is it?
Was that to do with orthogonal circles? Like the
Yeah, it
sensors?
was right after that.
Oh, so it didn't have to be orthogonal for the sensor to actually have some significance.
Oh. What was it? It was like.
What was this? Because of the orthogonality.
So it follows from the inversive definition of inversion that a circle and two inverse points invert into a circle and two inverse points. Blah blah blah. We can now combine inversive and Euclidean ideas in such a way to discover how inversion affects the center of alpha.
That's cool.
We might at first expect the center to invert into the other center,
Yeah,
but that would be too simple. It won't even happen.
Yeah.
Yeah. I guess we don't need the center to invert into the center or anything. We just need it to go right there. It's like no, I don't think I don't think it. I don't think we can. There's something I'm missing. I feel like we still could know inversion though. If we did like the exercises and stuff. It'd be
Yeah.
like inversion.
Easy.
Yeah. Like islands, like there's no problem where it's like walk through. It's like walk through with inversion, and like it shows you like how you would map points. Maybe was the IMO Q6 was a double inversion.
Yeah, well, so the guy who wrote Q6 is the guy who wrote the questions that I was going to give you today and tomorrow
Oh,
No.
for the TSD. Anand Montegal or something.
Are we doing this tomorrow?
What kind?
Are we doing
India.
this tomorrow?
Oh, did you want to do this tomorrow?
Yeah, sure.
Are you comfortable enough with these S's?
We've looked at
maybe.
We've
looked at a few, and
yeah,
if
we have
I can ask other people.
or any of the apps.
Well, basically done S2
Yeah, that's
and like all the problem one.
What the oh, right, yeah.
Or,
Somewhat like
or realize where they came from. And,
Yeah.
and we've
Yeah,
done one
okay.
before.
we've done one before. I just have to remember how to do it.
Yeah. Okay. Yeah, well, we can try. So I guess. So I was trying to mix it up. So the two exams, one of them was N. So the day one was the one that would have happened today was C3,
Uh-huh.
A1,
A1, G2.
G2, yeah. And the one that would have happened tomorrow was N1, A2,
G3.
G3.
G3 is not necessarily a good thing though. You can get more partial marks in C3. No, you can get more partial marks. And you're probably not consoled.
Yeah, but I guess that's a good thing because at least you'll try it. Because part of this is to get you to try
Question 3, yeah.
question 3.
So, I mean, if you just find all the ones with 0 as Q3, then you go and try it. That's the trick. And if you put C3, then everyone will try it. If you put
that's what I
polynomials, no one will try it.
You tried that for this one.
Yeah.
For the colours.
Oh, yeah, and he did try. And the problem was very easy. Well, you're right.
Huh?
Right? It was
Yeah,
very
yeah. The
easy.
solution was really easy.
Yeah. You just eat all of them and then.
She felt like probably the take your time message got abused. Take your time. Okay, we'll test out what that means. So, is that well defined?
I texted to take your time, and I never saw him again. I used to have 4 sons. I texted 3 times, take your time.
Okay.
Oh, did you like the table?
Yeah,
With
the
more
table's good.
It's easier for 2 people.
Yeah, probably not like with more.
Yeah.
Although,
Or the score.
although it's probably going to be 2 to 9. Disgusting.
Or
And
Sean.
Oh, yeah, sure.
3's alright.
Yeah, 3 should also.